You will get paper 2 very soon. You can see 150 marks, 3 hours. We'll start from there. And here we come. I'm not going to take you through the instructions, but I'll just take you through directly to the questions. Question 1 is climatology. Various options are provided as possible answers to the following questions. Choose the answer and write only letters under that. So what do? We are given a map here. We need to start by interpreting that map. The map you have here, we have got high pressure cell here, we have got which is in the center, which we know that if we have high pressure cell in the interior, which season is depicted? It's a winter season. Okay, let's quickly go to the questions. 1.1.1. The season represented in the synoptic weather map is obviously, like I said, it's winter. So there we quickly go, and the answer is D. Okay, so we go down 1.2. The isobaric interval of the isobars on the synoptic weather map is thus in hectopascal. We come here, we're looking at these isobars. These are the isobars. So when you look at this one, this is a high pressure, and this is 1024. Okay, so this is 10-20-20. That means as you are getting away from the high pressure, it's decreasing. But it's decreasing with what? 4. So that means A is going to be 1020 minus 4, which becomes 16. So 1016. So 1016, when you look at the various options that are here, but they say the isobaric interval. So the interval, that is the difference between the different isobars, is 4. So the answer becomes B. Okay, we go down. The air pressure reading at A, the air pressure reading at A, the air pressure reading at A, the air pressure reading at A is that hectopascal. Obviously, I've just told you that A is what? Minus 4, because this is 1024, 1024, 1020, so that minus 4, it becomes 1016. So 1016 is that option there. It's there, and therefore it is A. Okay. We go forward. Point 4. The dew point temperature indicated at the weather station B is dash degrees centigrade. We go to weather station B. Weather station B. The dew point. Of course, this one on top is the air temperature. The one down is the dew point temperature, which is 1. So the answer is 1. When you check the options that are given there, 1 is there, and which is C. So here is C. The weather station around the interior high pressure cell show clear skies due to dash A, and the anti-clockwise rotation around results into this kind of winds. So here we're looking at 1.5. And then let us look at the various options. 1 is saying subsidizing. Obviously, it's a high pressure. A is subsidizing. That option must be there. That option is there. Also, we have rising. Of course, it can't be subsidizing and rising. That one is out. So when we look at our options, wherever there is 2 is wrong. So that means this one is obviously wrong. Okay. So C is obviously wrong. We go to another one. Southwesterly direction. Or southeasterly direction. So there is Roman number 3 there. And when you look at Roman number 3, it can't be southeasterly when you look at this weather station. You go back here, and you check. If you like it, is it southeasterly? No, it is not easterly. We go back down there. Then we say, oh, that, of course, wherever there is 3, is also wrong. So this one is wrong. Okay. This one is also wrong because there is 3. This one is also wrong. Which option do we have? We only have option B, whereby northwesterly and subsidizing. And therefore, the answer here is B. Okay. We go. We have a diagram here that shows. So we are going to use this diagram to answer 1.16 and 1.18. So when we go down here, we're looking at the map of South Africa. We have the low pressure system here, which is the Mid-Latitude cyclone, and the anticyclone here on this other side. The first question is CC. So this and this is what? But you can see it's a high pressure. So because this is a high pressure, this becomes what? raging. So an elongated high pressure is raging. So the answer is A. Okay, 1.1.7, the high pressure cell D will cause weather system E to move in that direction. Which direction is that? So that 1.7, obviously the answer is B. Okay. So here we say D. So the weather condition at this station F is here. What is the weather condition? So the weather condition here is which one? Go down and we say air temperature is 8. Let's look at that air station. Air temperature is the atmosphere temperature at that station. Is it 8? No. The atmosphere temperature is 14. So meaning that 8 is number, where we have 8 is number 1. So in these options, wherever there is 1 is wrong. So this one is wrong and this one is wrong. Okay? So we are remaining with those two. Cloud cover is 4/8, which is a half. And therefore, when you look at the station model, it is a half. Therefore, do we have that 2 somewhere? So it is on this and on this. So we are looking for the other option that makes it very right. Southwesterly winds. Southwesterly winds. Obviously, these winds are southwesterly. When you look at it, you come here, it's southwesterly direction. This is southwesterly direction. So that obviously makes it. Wind speed note is 5. This one is not 5, it's 10. So that means wherever there is 5 is wrong. So where is 5? 5 is here. So the only option is B. So right there, B. Okay, we'll go forward. Refer to this valley climate. We have the valley climate here. What we need to do, this is a cold plateau. Here we have the shadow zone. We have trees here. You can see cold air of the drainage. You can see crop farming here. And they say south and this is north. That means this slope here is north facing. This slope here is south facing. Okay, and they show us temperatures. Minus. So here, actually here B is higher than up and low, meaning that cold, cool, hotter or warmer. Okay, so we go down there. See the questions. So we are using this to answer this question. So 1.2.1, the direction in which the slope faces in relation to the insolation. Yes, that is Z, which is Z here. The sketch represents the valley, which hemisphere? The hemisphere obviously is southern hemisphere. Why? Because the slope here is warmer than the slope. So the south-facing slope is warmer than, the north-facing slope is warmer than the south-facing slope, which makes it the southern hemisphere. So here is why. The next question is, dash wind occurs due to terrestrial radiation. Which one? It can't be anabatic because terrestrial radiation mainly happens late in the night. So why answers there? So 1.24, a temperature inversion occurs between A and B due to dash and or temperature and height. Obviously, the answer here is Z, which increases. Okay, temperature increases. So 1.24 is Z. 1.25, the form of precipitation that could occur at X. Here, it's very cold here, so you don't expect dew. It was only going to be frost. So Z is there also 1.25. 1.26, fog. Dash fog may form in the valley in the clear and calm nights. Obviously, that is a radiation fog. Okay. 1.27, the northern side of the valley is covered with trees because the answer is Z. Because of low evaporation. Remember, trees have cool environment, or they bring cool conditions. And there's less sun on that side. We go to the next question. The next question is a text. The text given here is the 2 cold fronts to heat Western Cape this weekend. So we have the date here, the 10th of June, 2022. And then they show us that according to South African weather, 2 cold fronts are expected to bring rain, strong winds, high waves, and significant drop in temperatures in South Africa. So the first cold front is expected to hit the Western Cape on Sunday evening, 12 June, ahead of the first cold front. Okay. So they say strong northwesterly to westerly winds between 10 to 60 kilometers per hour. gusting up to 80 to 70 kilometers per hour. So are expected over the southern part of the Northern Cape and the interior of Western Eastern Cape from Sunday. So the second cold front is expected to reach Western Cape by Monday evening, which is the 13th. You can see from 10th to the 13th. So bringing that continually high amount of rainfall, okay, etc. when you continue reading. So the first question is, which season do the cold front mentioned above influence Western Cape? When you look at the text, there are months that are given there, which indicates June. June is which month in Southern Africa? It's winter. Therefore, the season here is winter. Give evidence. The evidence is that the month given the text is winter. The June month. The June month. Okay. Then why do the cold fronts have a greater impact on the Western Cape during this season? Why on Western Cape during this season of winter? We must understand that this system moves with the movement of the ITCZ. So when the ITCZ is above the tropical or overhead the tropical Cancer, which is the northern hemisphere, it is winter in the southern hemisphere. So here we are going to say that because the ITCZ shifts, northwards, hence the system, hence the cold front as well, okay, following. Okay, so when the system moves northwards, the cold front also falls northwards and reaching Western Cape, which is the southern hemisphere. Okay, the change in the wind direction mentioned in the extract is what? Since this is southern hemisphere, we take backing. Okay, so the answer here is backing. Give a reason for your answer. Give a reason from the extract for your answer. It is given the extract somewhere. When you go back to the extract, they say the wind direction is associated with the cold front in the southern. No, it's not that one. And say somewhere they say that wind direction associated with the cold front will change from northwest to southwest. Okay, the wind direction associated with the cold front will change. That means the extract is here. Change from southwest to northwest, meaning that there is change in direction. So that answers this question. Okay, and that is the last paragraph. So this last paragraph here answers this question. So in the paragraph of 8 lines, suggests the positive and negative. We are talking about the positive and negative impact of heavy rains associated with the cold front on physical environment. They need the physical environment. So the positive one, I will start with positive. Under positive, we shall say it clears or cleans the atmosphere. Remember, when it rains, if the environment has been dirty, having toxic or those gases that are not right, when it rains, they will be brought down from the atmosphere, in that the air that is in the atmosphere is going to be clean. That is number one. Number two, another positive impact, that because it rains, this rain is going to be very important for the growth of vegetation. Okay, rain favors the growth of vegetation. Favors the growth of vegetation. Those are all positive. So under the negative one, let's say the negative, we shall have soil erosion. So, okay, let me say heavy rains, I would say that heavy rains contribute to soil erosion, which is a negative effect. Okay, then we can have another point here, and we say it also causes flooding. Causes flooding. Then you can also look at soil erosion coming because of heavy rainfall, which means it makes soils infertile because it will wash away the topsoil, which is infertile. But remember, I want you to note, learners, that all these ones are positive and negative. Therefore, I would like you to write them in a paragraph format. So you write them in a paragraph format. Remember, when you're writing a paragraph, it must be a statement that is making sense. So you make sure that it's a statement. You don't bullet. Please don't bullet. You write it in a paragraph format. Okay. We go to 1.4. 1.4 is an infograph which is showing the tropical cyclone. Okay. And then when you look at the diagram here, it clearly indicates that this is the center, which is the eye. Here are the eye walls, and you can see the cumulonimbus clouds here on the sides. Here air is rising, here air is descending. You can see the kilometers away from the center. So we have the graph associated with the tropical cyclone here. They are showing the air temperature and the wind speed. This is ahead of the eye. This is in the eye. So we also have the isobaric representation of the tropical cyclone, and we have a dangerous quadrant on this side. We have the symbol of a tropical cyclone there that can also tell us the hemisphere. You know very well, if this one is here, it tells us a lot about the hemisphere. If the symbol is like that, it also tells us about the hemisphere. If even the diagram, the arrows are like that, it also tells us about the hemisphere, which is the southern hemisphere. But we shall see as we proceed with the questions. Question 1 says, what evidence indicates that the tropical cyclone developed is in the southern hemisphere? You see, learners, if you first interpret the diagrams, it becomes easier for you to get the answers. See, by just interpreting the diagram, I would answer all the questions before even I look at the questions. However, let's say the first evidence that is in southern hemisphere is that air rotates clockwise. Okay, clockwise rotation of air, okay, into the low pressure system. Number 2, we can also look at the location of the dangerous quadrant. The dangerous quadrant is located in the southwest direction. So the dangerous quadrant is in the southwest. Okay, in the southwest. All right. We can proceed. Give 2 reasons. Give 2 reasons. But here is 1 mark. So don't mind, you can write 1 and get all your marks. Give your mark, get a full mark. Okay. Give 2 reasons from the infograph that indicate that the tropical cyclone is in a mature stage. What reason do we have to say that this tropical cyclone that we have here is in a mature stage? The first reason that we are going to give there that is in a mature stage is that the eye is visible. So we say well-developed eye. Okay? Remember, mind the mark allocation is 2 times 1. So there should be 2 points. Okay? Then we can also look at the pressure, the air pressure. Air pressure is below 1,000 MBs. Okay, the air pressure is below 1,000 MBs. Okay, so all those ones are evidence. You can give other evidence. The eye is well developed. Then you can also look at from the very infograph the speed. But because here it is indicated, actually, you look at the area covered by look at this one. It covers between 500 kilometers and 450 kilometers. So it has covered a wider area, which means it is in its mature stage where it is running at a rapid speed. So you can also give another evidence. The system covers a wider area. Covers a wider area. From 450 to 500 kilometers. That is a bigger area. Okay. Give a reason for your answer. But before we reach the reason for your answer, they say, how did the descending air at A influence the cloud cover in the eye? First of all, how means a way, a method. How is it influencing the cloud cover? Here we are going to say that the descending air, that means if air descends, what happens? If air descends, it simply means no no condensation taking place. No condensation. As air descends, there will be no condensation taking place. And therefore, if there is no condensation, it simply means there will be no dew point reached. That means there is no dew point reached. No dew point reached. And that influences what we call the clear skies that exist in the center of the eye. Okay. Then give a reason for your answer. Give a reason for your answer. We are looking at 1.4.4. Give a reason for your answer. Okay? The reason is that it influences, okay, this one influences the clear skies. Give a reason for your answer. We shall say no dew point reached. Dew point reached. Hence, clear. No dew point reached. That's why we can have clear skies. All right. Then we proceed 1.45. 1.45, they say, what is the relationship between the wind speed and the air temperature as indicated in the graph? We'll go to the graph. Here we can see the increase in what? Here it shows what happens here. That is, as the height changes, look at where the air temperature is, the air pressure. The pressure is high, away from what? From the eye, but the wind speed is low. That means when you reach here, the wind speed has been high, okay, but it starts decreasing, okay, in the eye. And then also the pressure starts to do what? To drop. So here we shall say that here at the ahead of the eye, okay, ahead of the eye, what shall we have? The wind speed is low. Wind speed is low, while the air pressure is high. Wind speed is low, while air pressure is high. That is the first relationship between, remember we're mentioning wind speed and air pressure. So what about within the eye? What do you see here? Okay, then the wind speed declines. In the eye, the wind speed is low, but also the air pressure is also low. So low wind speed, or wind speed is dropping as the air pressure is dropping. So wind speed dropping as the air pressure. Okay, so they basically, I've answered that question. So 1.46, why is B on the sketch or as represented to be the dangerous quadrant, the left dangerous quadrant? We go back to B. Why is this one indicated to be the dangerous quadrant? Okay, it's indicated to be the dangerous quadrant because hold on. Why is it referred to as the leading left quadrant or the dangerous quadrant? Because the rotating air and the direction of the system, the direction act respectively, the rotating air and the direction of the system, all act in the same direction within the dangerous quadrant. All act in the same direction within the quadrant B. Okay, then how does this leading quadrant semicircle develop? So we shall say that as A or wind, as A spins around the low system, the low pressure system, they coincide or they act in the spiral to each other. They act spiral to each other in the southwest direction. That's how it develops. That's how it becomes. So the speed at which it spins and the direction at which it is going, they are all acting in the same direction. And that results into them acting strongly, resulting it to be known as a dangerous quadrant. Okay. Then we look at the next diagram. The next diagram here. So remember I told you, learners, we interpret the diagram first. You refer to the sketch below. When you look at the sketch, it shows the cross-section of the South African relief. It shows here, on this other side, we have the Atlantic Ocean. Here we have the mountain. We have the Central Plateau here. Then we have another mountain on the other side. Here we have the Indian. So if you to name this mountain here, this is going to be the Drakensberg, and this will be the Table Mountain. So this is the interior, and there is a moisture front there. There is anticyclone here and anticyclone here. So there is air that is leaving this side can be interior, and there is air that is leaving this side can be interior. So if you're to name this anticyclone, since this is Atlantic Ocean, this is going to be the SAHP, South Atlantic High Pressure. It's going to be the South Indian High Pressure. So remember, learners, I said you don't look at the questions immediately. You first interpret the diagram. And when you interpret the diagram, eventually you will be answering all the questions nicely. So the first question is identify the high pressure A and B. And I think I've identified them. So A is SAHP, which is the South Atlantic High Pressure, and B is SIHP, which is the South Indian High Pressure. We proceed. Which season is represented in the diagram? Obviously, the season that is represented in the diagram is summer. Why summer? I would say summer because I think it's not as, but it's summer because in the interior you can see there is rainfall. Remember, the interior experiences this kind of rainfall during summer. Somewhere here we have the cumulonimbus clouds that are responsible for this kind of rainfall. Another thing, we have the moisture front. Then you also have the converging air. Remember, air converges if it's a low pressure. So a low pressure in the interior develops only during summer. Okay. So those are reasons that can be given. However, it's not asked, but we're trying to find a way of answering the question. Okay. The next question says, define a moisture front. A moisture front, now in this case, will be defined as, sorry. It says which season? The season is here, summer. So after summer, they said give one reason. So the first reason is converging cold air and warm air in the interior. Okay, then we can give another reason here is that the CB clouds, the CB, which is the cumulonimbus clouds, you can see it here, the CB of the cumulonimbus clouds that are evident in the interior, and that is responsible for heavy rainfall. And that heavy rainfall occurs only in the interior during summer. So the CB clouds and the heavy rainfall in the interior also explains that kind of what? Of season. Okay. So the fact that warm air and cold air can intersect in the interior, it tells us that. All right. Sorry for that. The moisture front. What is a moisture front? A moisture front is a moisture boundary, or the boundary that separates the boundary that separates the cold dry air from the Atlantic Ocean, cold dry air from the Atlantic Ocean, and the warm, moist air from the Indian Ocean. So that boundary separates the two air masses of different characteristics in the interior is known as a moisture front. Remember, these two air masses are formed of different moisture content. That's why we call it a moisture front. All right. Give two forms of precipitation that is associated with this line thunderstorm. First of all, you can see that there is heavy rainfall. Where precipitation is any form of water in the atmosphere. So we have heavy rains, and if you expect heavy rain, you can see some kind of hail within this kind of rain. So that means another form is hail. Okay, another form of precipitation is hail. The answer, the mark allocation says 2 times 1, so we have to give 2 answers. Describe the process involved in the formation of the line thunderstorm. What is the process involved in the formation of a line thunderstorm? So the moisture front already has developed. Okay, so if the moisture front has developed, what happens? So cold dry air, okay, proceeds to the interior, meeting with moist warm air. Okay, so when it meets with the moist warm air, what happens? The cold air wedges underneath, and the warm air rises along the moisture front, forming a line thunderstorm. Which comes with lightning and all that, with a line of clouds that forms on the eastern side of the thunderstorm. Okay, we go to question 2. Question 2, the first question says 2.1.1. A river and its tributaries is known as what? A river and its tributaries is known as what? We're looking at the river and its tributaries, so it means it's a system. Okay, a river and its tributaries is a system. Okay, if it had the word area or a zone, it would be a drainage basin. But since it's a river and its tributary, it becomes a system. So 2.1.2, in the high-lying area that separates two drainage basins, it becomes a watershed, which is A now. Okay, the two or more rivers join. Which one is that? They join where we have a confluence. So the answer becomes what? D. Next question. Refer to the sketch below and answer the questions. First question is, which kind of drainage pattern is represented here? You can see that it looks like a branch of a tree, which forms a dendritic. So that becomes B. Okay, 2.5.5, the stream order at X. We go to X. Where is X? X is here. So which stream order? So we say 1 and 1 is 2. So 1 and 1 is 2. That means 2 mixed with 2, it forms what? 3. So 1 and 1 is 2, so we keep 3. 1 and 1 is 2, so we keep 3. 1 and 1 is 2, so we keep, this is 1, so we keep 2. 1 and 1 is 2, so we keep 2 here. 1 and 1 is 2. So 1 and 1 is 2. This is 1. This is 1. Therefore, obviously, this is 3. So X is 3. And we have the third stream order there. Yes. So the answer is C. The drainage density of a drainage basin is high because it is influenced by the river flowing in the area and of and. So we come here. Obviously, we're looking at drainage density, amount of rivers that are existing on the surface of the earth. So, first of all, if it's less vegetation, that means there is more surface runoff than infiltration. So, this option must be there. So, wherever there is one, might be right. So, we are going to first see. So, do we have one here? Yes. We don't have one here. That is wrong. We don't have one here. It's wrong. So, we are remaining with C and B. Okay. So, we are remaining with C and B. So, when you look at C and B, the next one is high polar porosity. High porosity means there is more allowing water to go through. So that means if water easily goes through, it can't allow the what? The formation of high drainage density. So that one is right. So wherever you have 1 and 2 is wrong. 1 and 2. So 2 is here and 2 is here. That is wrong. But there is also another 2 here. Obviously, the answer remains high rainfall. And when you look at 5, 5 talks about high permeability, allowing easily water to go through it. So the answer is B. So the answer here becomes B, which is 1.1 or 2.1.6. Okay, so 2.1.6 is answered there. Okay, then we go to this figure. We are going to use this figure to answer question 1, 2.1.7 and 2.1.8. So here we have this figure that you can see that they are short tributaries in this kind of folded mountain. You can see this kind of folds. So that means this kind of tributaries, and we have the folded mountain, obviously tells us that it is trellis. Okay? It tells us that it is what? Trellis. Let's look at this. Tributaries of a trellis drainage pattern. You see learners, what I'm telling you. Try to interpret the diagram before you answer the question. So it is trellis there. What is the first question? Tributaries of trellis drainage pattern. Okay, so they join the main river at acute angle. That is wrong. It cannot be acute angle. Acute angle is less than 90 degrees. So wherever there is A is wrong. Okay, so acute angle is wrong. So 2.1.7. So they say join at 90 degrees, mainstream at right angles, which is 90 degrees. Bend 90 degrees along the course. That one we might not accept it. Then it flows away from the central place. That is wrong. So the answer is B. You can see it joins the mainstream. This is 90 degrees. You can see that. So the answer is B there. So the drainage pattern is found in this region. Which region? Inclined, jointed, uniform, folded. So folded is okay. Okay. So that means wherever you have 5 is okay. I mean 4. So there is 4, there is 4, there is 4. So this one is wrong. Okay. They say jointed igneous rocks. Okay, jointed igneous rocks. Then uniform resistant rocks. They say uniform resistant rocks. This is dendritic. So this one is right. It's wrong. Okay. And then talk about inclined. We say it's wrong. So the answer is 2 and what? And 5. 2 and 5 and 4. Sorry, 2 and 4. It makes it D. All right. Makes it D. Let's proceed. The next question says, we are referring to these 2 here, and we'll answer the questions that are there. So when you look at these 2, remember you said learners will interpret first before we look at the questions. Look at this. This drainage pattern is not uniform. This one is uniform. So when you look at this one is disrupted by a dam and by this hard rock. So there can be a waterfall here. So that means this is temporary base level and this is concave, which can refer or which can come to a permanent base level. So if it looks like this, that means there is a balance between erosion and deposition. So there is a C here, there is permanent base level of erosion. The first sketch illustrates which profile? A and B. A and B illustrates that profile of the river. So the cross is wrong. So this is longitudinal. Longitudinal means you see a river from the source to the mouth. The source is there, the mouth is here. The source is there, the mouth is here. So these 2 are longitudinal. Z answers that. So the temporary base levels of erosion is evident in which sketch? This is A. So A is Y. So Y is there. The profile of sketch B is which one? Graded or undergraded? Obviously, it's graded. There is a balance here between erosion and deposition. Y is answering that. Okay. Then we say the dominant process at X. We look at X here. X is here. The dominant process at X in sketch A is dash erosion. Can't be lateral. Lateral means the sides, the river widens, becomes bigger. Headward means erodes going back to the source or upstream. So that means the answer is Y. Because going to erodes here, going back to the source or upstream. Okay. We continue, and then when we continue, we are looking at 2.2.5. The permanent base level of erosion is in which one? A dam or a sea? A dam is in a course. So this is temporary, this is permanent. So the sea becomes Z. So in the profile, there is an equilibrium between erosion and deposition. Equilibrium between erosion and deposition, which is graded. And this is the cell. So it is B, which is Z now. Okay. Then we go, the river profile B. This B here, developed due to erosion of the temporary base level or the lowering of the watershed. The answer becomes Y. So it's erosion of the temporary. So when these ones are eroded, it becomes concave. Okay. We proceed. 2.3. Refer to the photograph. The photograph there that is indicated is a valley below. So you look at this photograph. When you see this photograph, you will find out that at least it is a very sharp valley. Now, here is a narrow valley. Here, it's a V, and so on and so forth. The interlocking, the spars are there. The first question is, the valley in the photo is generally found in which state? Obviously, it's the upper course. Can't be middle because this is a narrow valley. Okay, or a V-shaped. You can see a V formed there. Identify two characteristics visible in the photo to support your answer. Which characteristic? Number one is the narrow valley. Okay, very narrow valleys. Here, narrow valley. So besides the narrow valley, you can see the V-shaped valley is evident. V-shaped valley is also evident. Also, we can look at the interlocking spars. Interlocking spars. These interlocking spars that you can see there. All right. And also, we can also look at the color here of what could be the water. It is white. So that white color simply means it is in the upper course. Okay. So we can talk about the white color of the water. Okay, refer to sketches B and A, which is indicating the waterfall. So here is a waterfall there. So when you look at this, it shows how erosion will take place. But when you see there, it cannot take place at the same pace. This one, it was at the same level here. But when you check here, this one is further eaten compared to what is here, which simply means here, softer rocks, hard rocks. So if this one is soft and this one is hard, let's answer the question. What is a waterfall? A waterfall is the change in a gradient. Change in gradient, or when a river flows over hard rock down the stream. Okay, hard rock down the stream. So match Y, Z with the figure, and then in the sketch A with the concepts related to a hard rock and less resistant rock. So we said Y is a hard rock because you can see the rate at the speed at which it is declining is not the same speed. This one is declining. So because this one is declining faster, it is softer. This one is declining at less speed, it is hard. Therefore, here we shall say Y is a hard rock. So we say Y is hard rock and less resistant, hard rock, okay? And Z is a soft rock, which is less resistant, soft rock. So Y is a hard rock, which is resistant. Z is a soft rock, which is less resistant, okay? We continue. How does erosion in B, this B here, how does erosion in B cause the waterfall to retreat or move upstream? So we find out that at B, what happens? How does erosion in B cause the waterfall to retreat? Cause the waterfall to retreat. Erosion at B. So we come here, retreat or move upstream. So don't forget that as this water flows over this hard rock, okay, as water flows over the hard rock, okay, we say as it flows over the hard rock, headward erosion takes place, eroding softer rocks, leaving behind, eroding softer rocks faster than the hard rocks, at Y, leading to retreat upstream, Okay. Refer to the sketch below on this river rejuvenation. So we have this sketch below regarding river rejuvenation. Okay, we can have the terraces. You can see the terraces here. You can see the new valley, meaning that this is the old valley. This is the new valley that is formed in the old valley. It is this river that is meandering, flowing in that direction. So there is A, there is B there. So here it is indicated that these rocks that are here are a bit softer. What is river rejuvenation? Here we say when a river gains its erosive power, or I say when the river develops the characteristics of the upper stream while it is in the lower course. State two possible causes of rejuvenation. What could cause rejuvenation? Number one is heavy rains that increases the amount of water in the river, okay, that allows it to flow faster. Then we can also say change in the gradient. So when the gradient becomes steeper, the river will erode more. Okay, we can also talk about drop in the sea level. Okay, all that assists our rejuvenation to take place. Okay, the next question says that draw a freehand cross-section of from A to B of illustrated rejuvenation. So here we look at it freehand from A to B. What do you see? You draw what you see. Here it comes down, here it comes down, you drop, it comes down, step-like feature. So what we are going to do, we draw this one. Okay, so let's see. Let's see here, it's going to be freehand cross-section. He said freehand. That means they want us to indicate the shape of the rejuvenation, the shape of the rejuvenated valley. So this is the rejuvenated valley, which is the new. So we say rejuvenated valley. And then they say indicate the new valley. This is the rejuvenated valley. So the new valley is this one. New valley. When you look at the shape here, you clearly see, check here, you clearly see that here and here. So this is the new valley. So it's no longer wider, it becomes a bit narrower compared to what it was before. Then it say indicate the terraces. The terraces, the river terraces, those are the steep-like features that are left out. So these ones are the terraces. Those are the terraces. Okay. How did the river terraces illustrated above form? They form due to, so we shall say, when the river gains more energy, okay, what happens? It erodes the valley in the new valley. It erodes the old valley, forming a new valley, leaving the terraces behind, leaving the river terraces, Okay, let's go. 2.45. Explain how the illustrated landform will negatively impact on infrastructure development. That means if a valley is formed in another valley, it becomes very difficult for infrastructure to develop. So we'll find out that flooding, when now it's the landscape becomes steeper. Therefore, when it becomes steeper, what happens? It becomes difficult for infrastructure to develop. The valley becomes steeper because now a new valley is eroded in the old valley. So the landscape becomes steeper. Number two, also we can say that when it becomes steeper, it simply means that also the water flow increases, the speed increases, and when the speed increases, erosion takes place. Erosion also increases, and this increased erosion means it results into, or it makes it difficult to construct for infrastructure development. Okay? For infrastructure development. So that is 2.4.5. We're looking at 2.5. 2.5 is an extract. It's an extract that is given about the river catchment area and river management. So you read it, talks about the river turns black after coal mine dam collapses next to the rural community in Flutulwe, Mufolos Game Reserve. So what happens here? Large volumes are potentially toxic coal mine waste have been spilled into the rivers flowing through communities and Flutulwe, Mufolos Game Reserve. Okay, according to the US-based Union Concerned Scientists, mining and coal washing operations produce high water pollution, which can also contain toxic heavy metals such as arsenic, copper, lead, and manganese. Okay, when the Silari Dam wall collapsed on the 24th December, the residents of the affected communities were not warned about the potential hazards until 2 weeks later. Conservation managers in the neighboring Uthuluwe Buffalo's Game Reserve were also led to believe that the spill was under control, only to discover pitch black water flowing through the reserve several days later. By this stage, the black water had reached the confluence of black and white Umuforos rivers. Okay. So that is the extract. Let's see the questions. First question here for 2.5.1. What caused the river to change its color to black? Number one, it's a 1-mark question. Therefore, it is because of the toxic coal mine waste that spilled into the river. Okay. toxic coal mine waste that spilled into the river, making the color black. So I think the answer is somewhere here in the first paragraph. So state 2 toxic heavy metals. So there is lead, there is coal, okay? It's copper. Is it coal? Is coal there? Oh, sorry. I think I haven't seen coal. Oh, coal is there. It's copper, there's coal, there's lead. So all those minerals are here. Copper, there's coal, there's lead, okay? Manganese, all those ones. The answer is just 2 marks. So I'll just take 2. Okay. Quote the phrase from the extract that indicates that the mining company did not disclose or make known that the pollution of the river. So we find out that somewhere here they say the residents, okay, but residents somewhere here they say when the dams collapse, when the Slurry Dam wall collapsed on 24th December, the residents of the affected community were not warned. That means they were not informed. So this one up to here about the potential hazard until 2 weeks, it answers this question 2.45. 2.45. So what could have been the negative economic impact of the non-disclosure on the community? That means if you did not disclose it to the community, and this water spilled, this toxic gas is spilled in the water, that means there would be lack of drinkable water, so the water was polluted, so the residents were affected when they are unaware, because the water was now the water that is there was now the water that was available was now toxic. So here we are going to say lack of drinkable water. Okay. Next one, that is in the paragraph of approximately 8 lines, describe the environmental. It's basically saying describe environmental importance of managing inverse drainage. And that means the question is 2 parts. It has got measures. We need to suggest the measures that the local community or municipality could implement to maintain the future quality of water. So we need to first of all know the negative importance. Describe the environmental importance of managing forest drainage. So if you manage the drainage system like forest, how important is it? It's going to be important environmentally because it will help to preserve or to conserve. It helps to conserve the aquatic life. So if it is well managed, it will help to conserve the aquatic life that will be found there. Okay. Number 2, also those are the habitats now that are there. Okay. It also helps to keep the water clean. If it's well managed, it helps to keep the water clean. Okay, so we said the first one, conserving the aquatic life. Number 2, it helps to keep water clean. And it also helps I'm still looking at the positive. It also helps to conserve the vegetation. The vegetation that grows next to the river. Remember, the question says paragraph, so it should be written in the paragraph format, despite the fact that I'm outlining it. So those are the importance of managing. If you manage it, it's okay. All this will happen. The next one is measures for the local community to implement so that in the future they can have better quality water. The first one, under the suggestions, is going to be buffering of the river. So when you buffer the river, you're protecting the river. Okay. We can also, the measure that can put in place is educating the masses about the importance of maintaining the river. The importance of maintaining the river. After educating them, you can also say measures that can put in place that punish the polluters. All those ones that are polluting the environment, punish them. You can also reward those ones who try to maintain the water sources, but you write it in the paragraph formatting. Okay. We got the last question, that is question 3. Question 3, it talks about map skills and techniques. So here it's coming from Xerast, which is northwest. Okay? The province is northwest. You read this information, is very relevant. So don't just jump it. Xerast is a commercial town situated in the northwest, which is the northwest province. Okay. It is situated in the Marico Valley, approximately 1,294 meters above the sea level. The town is 240 kilometers northwest of Johannesburg. It lies along the N4, the main road link between South Africa and Botswana. The climate in this area is characterized by short, cold, and dry winters and long, warm to hot summers. Rain is frequent during the summer months. 2 rivers flow through Xerast, that is the Klein Miliko and the Kari Strip in Xerast. There is a natural spring at the Miliko Orb. So that information is very relevant, so please don't jump it, you read it. First question that comes here is map scale that the grid reference of a spot height 13, 15 in block B4. So here I have the map. They said B4, the grid, the spot height is here. They want the grid reference. Remember, we start with the latitude. Latitude is 25, but the first line is 30. That means the second line is 31. So it should be 25, 31. Because it is here, it's more or less halfway. Okay. So we come here, let's see the options. So that means this one, the longitude should be 26. If this is 4, this is 5 here. This is 6 here. And this is 7. So it should be 2607. It should be 2531. Let's go and look at those options. 25, 31. So the ones that are starting with 26 are wrong. So there is no way the 26 can be the latitude. Remember, we start with the latitude. Check here. The latitude is 25. So since it's 25, whatever has 26 as the first line, on the first line, is wrong. So these 2 are wrong. So let's come to this one. When you check this one, it says 25, 31, 26. It cannot be 25, 7. So if you come and check here, it's 25, 30, 31. So the one that starts with 31 and it starts with S, and the rest is fine. So the answer is B. Okay, we go forward. They say the straight line distance from 1 in block A1 to Klipfontein Neck on the orthophoto map is dashed in kilometers. Okay, let's check on the map. Sorry for that. Let's check on the map. Question says, in block A1, on which map? Orthophoto. We come here, the orthophoto is here. Cliff-Fortnite is here. Okay, so from 1 to Cliff-Fortnite is here, but Cliff-Fortnite is not exactly located here. Cliff-Fortnite is 100 kilometers to reach it. So that means we need to measure from here to here. The answer we get, we convert it to kilometers so that we can add on to this one. So it's going to be the distance you measure from 1 to this place here, Cliff-Fortnite. Don't forget, from 1 to Cliff-Fortnite is if you measure it with centimeters, it's if you measure it with centimeters, it gives you somewhere around 4 centimeters. So 4 centimeters times 0.1. When you multiply it, 4 centimeters times 0.1, it gives you 0.4. Okay, that is the distance from here 1 to the end of the map. But from the map to reach Cliff-Fortnite is 100 kilometers. That means plus 100 kilometers. So you get 100 kilometers, 4 kilometers. And that answer is D. So this one is D. Okay. Remember, we multiply by 0.1 because the map that is given to us is orthophoto map. Okay, refer to the orthophoto map. Coming to the topographic map. The first question says, calculate the average gradient from the spot height 1463 at F to the block in block A2 to the benchmark at G in block C2. So we come here, use the relevant information. The horizontal equivalent is 300. So the horizontal equivalent is 3,000 meters, which is given. So we just need to find the vertical interval. We come here, he said spot at F, you come here, where is F? F is here, and the height at F is indicated there, which is 1463 meters, and to the spot height, is it no, to the benchmark? The question says to the benchmark, and where is the benchmark? What is the height of the benchmark? We go to that block, want to see the block. They say the block is C2 at G. When you check G here is C2, so the area is here. Okay. Sorry, it's not clear, but I'll try to zoom it out and see. Then when you zoom it out, you'll find out that the benchmark is here. Therefore, the height for that benchmark is here, which is 1,183.3 meters. So what do? Come here, we say VI is equal to, so we have 1463, which is the biggest, 1463 meters, minus the lowest of the benchmark, which is 1183.3 meters. The answer you get here is 279.7 meters. That is the VI. But remember, the HE is given. We apply it in the formula. So it's going to be 279.7 meters over 3,000 meters. So divide by 279.7, also divide by 279.7. This goes into this once, over this goes into this how many times? When you put on your calculator, it will go in 10.7 and others. So the average gradient is going to be, therefore it is 1 to 10.7. Okay, 1 to 10.7. So go ahead. Use the topographic map evidence and your answer. That means we need to use the map and the answer so that we can give the reason why it will be difficult to construct a road between F and G. We come here. When you look at F, G is here, okay? And when you look at F, F is here. What do you see? We see contour lines close to each other, which means it's mountainous. So the first evidence from the map is that it will be difficult because the area is mountainous. The area is mountainous, evidenced by the contour lines close to each other. Okay, so that is evidence from the topographic map. What about the answer? The answer given is 1 unit moved vertically, 1 unit vertically represents 10 meters horizontally, which means it is steep. So it becomes difficult for you to construct a road where it is steep based on the answer given. Okay. Wow, sharp. Let's proceed now. Refer to the rough cross-section that is between 2 in block A2 and 3 in block on the orthophoto map. We come here. Let's look at our orthophoto map. They say it is between 2 and 3. 2 and 3. I'll try to zoom it out such that I can be in position to see my features. 2. So 2 is here and 3 is here. So you can see this nature, this nature, this nature. And when you look at it roughly, this is a cross-section, right? So the first one is convert the vertical scale on the cross-section to the ratio scale. What is the vertical scale? It's a representative scale that is given here. So 1 centimeter represents 20 meters. So how do we change this one? This is the same as 1 over 20. And when you change this in the ratio form, it is 1 to 20. So that is the ratio form of the scale. 1 to 20. Okay. Then what does the vertical exaggeration of 5 times mean? It means geographical features are 5 times larger or exaggerated, making it visible. So it is 5 times bigger. 5 times larger or bigger or exaggerated. Okay. We go to 3.2. 3.2, it's interpretation now. 3.2. So 3.2, we're referring to the block, refer to the block dash in E2, and that indicates the season of the rainfall. Dash is in this block E2 on the topographic map is indicating which season of rainfall. We got the topographic map. Okay. Topographic map is here. Therefore, when you look at this topographic map, we go to E2. E2 is here. And when you check it here, what is the question? Which rivers do you see? You can see that these rivers are real broken. And they gave us a guide to say it indicates seasonal rainfall. So which rivers indicate seasonal rainfall? Of course, it can't be rough trees. Okay. I mean, which indicator here is for seasonal rainfall? Rough trees is rough. Rainy river is not seasonal, is rainfall throughout the year. Cultivated land is not answering that. The answer becomes C. Okay. So here they say, refer to the graph. Here is the graph below that is indicating the average temperatures from H to what? To J. H to J. So H is here and J is here. And here they're showing the temperatures here are higher, temperatures here at J are lower. Let's see on the map. What do they say so? So H is here, which is an urban area, and J is here, which is basically having rivers and so on. Okay, so let's see the question. What do they say? Identify the human activity or the human feature that was responsible for the higher temperatures recorded at X. Here we go to X. And according to X here, X is H. So H is here. Why do we have higher temperatures here? So we have higher temperatures because that area is a built-up area. Built-up area. Or we can say urban area. Okay. Explain your answer. Explain your answer. So we say, let's find the human-made picture, built up or a city, built up area. Yes. Explain your answer in 3.2. So 3.2, the urban infrastructure or the built up area. Okay. Buildings, here we say buildings. Built up, the human feature is a built up area. The human feature here, buildings. So human feature here, buildings that are responsible for the higher temperature. So the high buildings. The high buildings, which is the built up. So we say buildings absorb heat, making the city hotter. Buildings absorb heat, making the city to have higher temperatures. Okay, identify the natural feature that resulted into lower temperatures at Y. Let's go to Y here. Let's go to Y. Come on, Y. Y. Which natural feature? So identify the natural feature. Identify the natural feature. Identify the natural feature. Identify, the question says, identify a natural feature that resulted in lower temperatures at Y. When you come in here at J is where Y is. Which natural feature is there? You can see when you see this, there's a river there, isn't it? River, it helps to cool the environment. It's also that green vegetation, this protected area, which makes it the green vegetation. Okay, so here Here, the natural feature here is the perennial river. The perennial river. Okay. Next thing is which sketch below represents the slope from 4 in block C1 to 5 in block B1 on the orthophoto map. So we come to the orthophoto map here. Come to the orthophoto map here. The orthophoto map here, we are looking at 4 and 5. 4 from 4 to 5. This is a higher area, it's a lower area. So the contour lines are increasing going upwards. When the contour lines are increasing going upwards, it tells us A. Okay. Refer to the orthophoto map. How did the topography or relief of the area favor the location of the rifle range? Let's go to the rifle range. The rifle range is here. It's mountainous, it's mountainous. It's mountainous, it's mountainous. What does the rifle range, what is it used for? This is used for people who learn or train how to shoot. So if you're shooting, learning how to shoot, it's the mountain is favoring. Okay, the relief in the area favors because the bullets end in the mountains, or the mountains, you can say the mountain shields the areas around. The mountain shields the areas around. The mountains shield the areas around. Okay. The mountain shields the area around. That is 2.6. I mean 3.26. 3.27. Describe two factors on the topographic map that limited the pollution of the Kleinfilm Dam. You come here. Where is the dam? The dam is here. Which two? But the question says two factors on the topographic that limited pollution. What limited pollution there? First of all, the first factor that limits pollution is that the dam is located in between mountains. Okay? It's in between mountains, number one. Number two, it's close or it's located next to the protected area. So here you can see this is a protected area, and when you look at the nature of the relief around, it's mountainous. It's mountainous. So here we shall say the two factors is located in the protected area. So no just accessibility at any time, protected area. Number two, the mountainous nature around. Around the dam. Around the dam. That means it limits people's settlement. Therefore, there will be less pollution in the area or on the dam. Look at the last section. The last section says, which one of the following is a standardized point symbol? Obviously, that is found on the topographic map. This is not a point, that is a polygon. C is a line feature, and this road is a line feature. The only point feature is B. Therefore, the answer here is B. That is the only point feature. Okay? And when you check here, let's go to the topographic map and look for it. When you go to the topographic map and look for it, it is somewhere here. Okay? That is where we have our point feature, which is a monument A monument is a point feature. Okay. Give one attribute. Oh, now identify the alphanumeric block on the topographic map on which the point symbol is located. We go back to the map. Alphanumeric. What is the alphabet? It's located at alphabet C. And then what is the numeric? The numeric is 3. So it is C3. So here is C3. Okay? Then the last question, it says, give one attribute data of the point symbol on that answer, evident on the topographic map. You come here, this point symbol has got a name. What is the name? The name here is Graphendifercus. Okay, so you write it here, Dendritic Codes. So 1820 to 1891. Okay, the last section of the paper says, identify the GIS component A. GIS component A. Where is A? A is here, and therefore, that is, we call it people. Okay, the component is people. It's an individual, GIS specialist, people, person, or GIS specialist, whatever. Give one reason why GIS component, answer the question, is important. Why the GIS component in that question above is important to interpret and analyze data. Okay, also helps in data application. Okay, data integration is illustrated in the sketch. Give one reason to support your answer. Okay, several features are merged on the same paper or area. So you can see this one was separated, and then there are some lines on this map. So they are all merged and they're all appearing here. So you can see this one was separated from this, and later it's put in one area. That is in integration, trying to interpret or to put the data together. You integrate it, you add it onto. So the features are all merged in the same area or in the same part. They are put together, they are integrated together. So that marks the end of the paper. Thank you for listening. See you when we are doing paper 2. Bye.
Hello, good day learners. Godfrey is here to continue with the section that we left hanging, and that is the section for map work. Okay. And last time I was busy teaching or telling you regarding the interpretation of maps, calculations, application of geomorphology topic, and now today I want to look at other related concepts to the application. Now, when you're given a map extract, please learners first understand that the map we'll be having this kind of things. There is what we call reference. Reference is a key. It's the key that you're using to try to interpret what is on the map. And if you look at it clearly, one side is Afrikaans, another side is English. So for those ones who are understanding Afrikaans, you can use the other side, this side here. For those ones who are understanding English, you can use this side. But now I realize that some learners are struggling to understand what the key or the reference tries to refer to. Please listen, learners. It's very important to understand what the different symbols or conventional signs mean. A case in point, we have got this part here, this part here. We have got this part here known as the national road. And if you want to see what the national road shows this first part, which is blue in color. Okay. Then this other national route, it shows this other part, which is red in color. So when you're interpreting, you must know that this one, the first one is for the first line. The second one is for a second line. We have the arterial route. You can see that arterial route, there is one word. And if it's one word, you can see that it's completely one word. It's all red color with R in between, which means it's the arterial road. The main road, you can see it, same color. When you look at the secondary road, I want you to see the secondary road simply means this road that is having this kind of color. But now there is a benchmark. The benchmark is this symbol here that you see. Okay. Other roads, this one, and the bridge is that sign that is just on the other roads. Tracking and trail, you can see track and hiking trail, railway station, and the high railway station or siding. You can even see this black color here. So this is this symbol here, or this convection sign, is for a station. Embankment, you can see this is embankment here, and then you have the cutting, which is this other side. Okay, the power line. In other words, you can be in position to interpret these symbols. I want you to look here. Somewhere here we have got a post office. Okay, there is a police station and there's a store. Post office is P, police station is PS, and store is W. That is its conventional sign. A place of worship, school, and hotel. This is a place of worship K, school is S, and hotel is H. Now that is how you need to know to interpret the symbols. So the reference is basically assisting us to understand what is supposed to be on the map. So in this case, if there is anything that you do not understand and you just look at it, please don't just look at this reference as just given information just there. It's not irrelevant. It's very, very, very relevant for you to be in position to pass or to understand what the map means. So we must understand what each one imply about the mapped area. It's not only those symbols you see there. There are some other symbols. You can see these ones here. I know when you look at the kind of maps you have, in most cases, you will find that some symbols are missing. But in case you have been doing with these other maps, you will see that a lot of symbols are existing. But now other symbols, you must be knowing them in your head, such that you can be in a position to interpret them nicely. Take an example. The national boundary and the beacon. See that? The national boundary, this kind of line here, and then the beacon, that other kind of line. Then there is a provincial boundary that looks like that. It's a bit different from this one. You see, these are 2 dots. These are 3 dots. You see that? So you don't take things for granted. Take everything very relevant. Take everything very important, such that you can be in a position to work with it. We have here a water tower, a reservoir, and a water point. So this is a water tower. Okay, a reservoir. This is a reservoir here, and then a water point. Water point is abbreviated with F. Then we have a coastal rock. So this symbol is for a coastal rock, and so on and so forth. So in other words, I wanted you to understand that in map work, every symbol, everything you see has got value. Okay, so you must be in position to interpret. So before you proceed with understanding both the geomorphology, the climatology, how settlement is applied, how economic geography is applied, please start by understanding what the reference means on the mapped area, such that you can know that this is this one is this one, this one is this one, and that will assist us to be in position to interpret what we have on the map. Okay. Like I told you that it is interpretation. All right, learners? It is interpretation. With interpretation, we must make sure that we apply all the theory that we have learned so that it can be seen on the map. Take an example. We have looked at the aspect, valley winds, climate, slopes, landforms, settlements, land use, and all that. So we must be in position to interpret all those aspects on the map. Okay, so I want you to look at this. What do you see here? Here, you can see the issue of aspect, valley winds, climate. You can all apply it here, and settlement by just mere looking at what each part is meaning. Take an example. Okay, that when you look at this kind of map, and when you check somewhere here, you can see that the contour lines here are depicting that this part here is steeper than these other areas, which is basically a slope, a steeper slope here compared to what is happening this other side. Okay, then here is a protected area, natural protected environment that can be a game park, a game reserve, and so on and so forth. So you must be in position to interpret that. When you look at this one, what do we see in terms of drainage? You can see that this is a high-lying area. So these rivers are all draining outwards, which forms a kind of a pattern drainage in geomorphology that we call dendritic drainage pattern. And when you check somewhere outwards here, it's lower than what is happening here. Okay. Now, you can see this part here. I want us to be in position to interpret the economic activities. What do we see? When you see this, this is showing the cultivated land. Okay. And if they talk about the cultivated land, what do you expect? You expect activities like agriculture, you expect activities like farming, and so on that is likely to take place in that area. And to make it easy to understand, you can easily interpret that this cultivated land is basically located close to the dams, near the rivers and the furrows, meaning that they can easily have access from the dams to these farms, and they use it while practicing agriculture. Okay. Besides that, there are some other activities that we can look at here that we can think of. Take an example. If you see here, this is an excavation. Okay, that means there's some kind of mining taking place. In that case, okay, then you can also look at this place. That this place has got mining being practiced. Take an example. We have what we call the Western Platinum. Okay, Western Platinum mines, meaning that there is mining taking place in this area. In other words, this one can help us to interpret the economic activities that are taking place in this locality. Okay. Now, we go ahead and look at the aspects. All these ones are applications or interpretation of theory or map work with the different topics that we look at in geography. So, like I told you, that all aspects we look at are applicable. Landforms, microclimate, farming, recreation, conservation, and so on and so forth. So when you check here, what do we mean by conservation? This is the basically the using of the protection of the environment or preserving of the environment for future use. When you take this area here, Maharisberg protected natural environment. So Maharisberg protected natural environment is basically a conserved area, meaning that conservation is taking place here. Okay, when you see the cultivated land, what does that mean? Maybe there is farming taking place here. And when you see that this is a little bit steeper, what do we look at? We can think of the slope aspects. Okay, we can also think of a microclimate, that the climate that is affecting very small areas. So in other words, all those ones are trying to assist us understand the interpretation of maps using the different topics. Okay, so learners understand that anytime, any day when you're writing your geography papers, you're going to find out that those topics are going to come your way. You must be in position to apply what you have looked at in theory. It is going to be very difficult for you to understand the concepts when you have not applied the theory, or when you lack knowledge in the theory. Take an example. When you look at this slope aspect and you check this side, there is a lot of green compared to what is happening this other side. Remember, when you talk about slope aspect, you look at where the sun is facing in relation to where the slope is facing in relation to the sun. Meaning that on the shadow zone, we said that that place is cooler. Okay, so if you're in the southern hemisphere, the south-facing slope is much more cooler than the north-facing slope. What does that mean? The south-facing slope can easily favor activities, can easily favor activities like the growing of forests because it's cool. Remember, trees need a cool environment. And when you check this other side, there's a lot of green this other side, and there's a lot of cultivated land this other side compared to what is happening on this other side. So I want you to be in position to apply, that is application. Okay, be in a position to apply. All right. Now, we can also apply other topics. Both settlement. Here we have what we call the shapes of settlement, landforms, land use, and topography. When you check around here on the maps, what do we see? We talk about the shapes of settlement. How many shapes do we have? We've got a lot of shapes. For example, the linear shape. Okay, that is when the settlement is along a line. A line like what? Like a road. A line like what? Like a railway line. A line like what? Like a river. So in this case, if you see a road like this, and there are settlements along the road, which settlement shape is more likely to be formed if it's along a line of a road? Okay, the line feature that would be there will be a road. And if you see this road, that means you will know that the kind of settlement shape is a linear settlement that is taking place. Okay, so besides linear, we have got what we call the star shape. Beside the star, we have got another shape like that is a circular shape. That is, for example, when the settlement is around the circular features like mountain, like lakes, and I understand. We have also what we call the semicircular shape. For example, at the coast, ocean side, you'll find that kind of settlement. Okay, so if they ask about the settlement pattern, what do you expect? Settlement pattern, I will look at the layout of settlements in an area, and you find out that it's either nucleated pattern or sparsed. Okay, nucleated or sparsed. If it's nucleated, simply means when the settlements are within one area. If it's sparsed, when the settlements are spread. So what will you see? You'll find out that there are some areas where you'll see a lot of settlement. Actually, you must know that these are settlements here. So if it is concentrated in one place, it's nucleated. If it is dispersed, or if it is they're spread away from each other, it is dispersed. Okay. Now, besides that, learners, we have also the interpretation in relation to the settlement types. Okay, we say the settlement types, that is rural or urban settlement. Then besides that, we have the settlement pattern, which we said that it is either nucleated pattern or nucleated, which is the same as clustered, or dispersed, which is the same as spread pattern. Then you have the street patterns. When we talk about street patterns, what do we see? We're looking at the way the streets are being arranged. Okay, and in this case, what do we see? Look at this, learners. We know that in our settlement, you must have looked at what they call, okay, in terms of settlement pattern, said we have nucleated, okay, then you have what you call dispersed. And when we talk about nucleated, settlements close to each other, then here is settlement far away from each other. Okay, so if you check on the map, do you see anywhere where the settlements are so close to each other in one area like that? So that one is going to form a nucleated settlement pattern. What about dispersed? Dispersed is going to form something like this when they are spread from each other. Okay, that is settlement pattern. Then the street pattern. Street pattern, we have basically there is grid. Okay, we have planned, but planned, we have planned regular and planned irregular. Okay, then in this case, if it's gridiron, it forms kind of grids, squares, straight, and normally it is one way. So when you check around here, what do you see? You can start list here where they form a grid pattern. See that? Okay, and see maybe around here forms a grid pattern. Okay, then these other ones, like this one, is planned irregular. Then you have that one that is not having a proper shape, where the settlements are just spread out. The roads are just put anyway. So that one is irregular. But when you check there, you'll see that there is one which is planned, there is one which is grid, and the one which is irregular, or planned irregular and planned irregular. Check here. This is a very good example of grid street pattern. This is a very good example of grid street pattern. It's a very good example of planned regular. But if it is irregular, it simply means it is not making a proper shape. Take an example. This is unplanned street pattern, because the way they appear, streets are joined anyway, the way they want them to be. So that is interpretation of settlement. You are applying the concepts of settlement. And that settlement concept, remember, it is coming in paper 1, I mean in paper 2, and the economic geography is also coming in paper 2. So climatology and geomorphology is the application that is coming in paper 1. So learners, get ready for those aspects. Be in position to interpret them, and then life moves on. So you need to pass as we expect. Okay, now, like I've been telling you that we have a lot of things to apply. We have those areas that are flat. We have those areas that are steep. And how are they applicable? How are they important? If you look here, learners, we have fields here. We have canals. We have rivers. What do they all do? They all provide water for the farmers. Okay? The dams, they also do the same. They store water that is used during the dry season. Okay, so please, I'm trying to show you some of the aspects. Now, we can also apply another concept somewhere here. I want you to look here. This place here, because of the nature of the contour lines, it simply means that it's a bit gentler. And that means a gentle slope encourages the development of transport routes for easy accessibility. Now, check here. There are a lot of roads that are running around or running along this area because it's a bit flat. I want you to look at what is happening this other side. Because of the nature of the contour line, somewhere here, it is very steep. Therefore, because it is very steep, it discourages the growing, the construction of roads. And the same thing that applies here. Okay, that's why you see there are many roads here. If you check the only road that is here, it is passing where it's a bit gentler. In other words, between the two high-lying areas. You see this is a mountain here, it's a mountain. So this one we shall call it a pass, okay, or a gap where the roads are passing. Okay. Now you can see that this road, maybe it would have a chance to just come direct through here if it wants to proceed, but it couldn't. Why? Because of the existence of the steep area. Therefore, the road tries to pass around so that it can connect to other areas, because those steep areas are very difficult to construct roads onto. So hope learners, you understand. Okay, we are still looking at interpretation. Whatever that I see that is really important for interpretation, I will please try to explain. Okay, there is another aspect that I also want to talk about that is related to interpretation. That is the direction of the rivers and the direction of the rivers. Okay, let me start from the direction of the rivers. Direction of the rivers, I want to use this river here. They can ask, what is the direction of this river here? Okay, I might not be having a name for it on this map, but maybe it will have a name. Now, let us use this as our example. where does the river flow to? Do you think this river flows from the north to the south, or it flows from the south to the north? Who'd have thought? But in real sense, this river is flowing from the south to the north. Why? Because of the dam wall. It's not having tributaries. Look at the dam wall. The dam wall is this side, and this is where the dam is, meaning that the water is flowing from here, then through the dam wall, it goes north. That is number one. Number two, which other evidence do you have to show that this river is flowing in a northerly direction? Is because of the nature of the contour lines or the gradient. Check here, learners. You see here is steeper, here is flatter, meaning that the river flows from a higher lying area to lying area. So this river cannot be flowing from this way, entering where it is mountainous. It can only flow from the side that is a little bit mountainous, going downwards. Because remember, a river is a flow of, or is water that swiftly flows from the source to the mouth under the influence of gravity. Okay, so this river cannot climb the mountain, but the river flows from a higher lying area to down or to downer areas. Now, besides this, there is something that I want us to apply still. Look at this other part here. When you check that part, which stage of river do you think? Which stage of the river do you think this river is called what? Swartkopras River flowing to? Where does it flow to? And then the next question can be, which stage of this river? And then they can also ask some related aspects of river buffering, the buffering or the buffer zones. But before we reach there, let us start from here. When you look at this river here, look at the way the shape, the pattern is forming. It's forming this meandering pattern. And besides that, we look at the nature of the contour lines. It's not that so steep. And it is not that so flat. So when you look at this area, we understand that this river is in its last section. It's in the last course. So if it's in the last course, this is what we call meandering. Okay? And remember, in the meandering sections, there are some aspects we looked at. If it comes to meandering, remember, we looked at aspects like what? We looked at aspects of meandering. Then we looked at issues of the slip off. Then we looked at another issue of the undercut. And we know that if we talk about the undercut, what are we referring to? We are referring to the area that is experiencing erosion. When we talk about the slip off, we are referring to areas that are experiencing what? Deposition. Meaning that the slip off is what we refer to the outer, to the inner bend. Inner bend. And the undercut is what we refer to as the outer bend. Let us check on this river that we are having. If you look at this river that is flowing like this, meaning that as it keeps on curving and bending, we have the inside part, which we said is the inner bend. Therefore, this one is formed by deposition, and the outside bend, which is formed by erosion. So outside is erosion, inside is deposition. And you know, when you talk about erosion, what do we expect? We refer to the fast flowing water. Then we talk about dominant activity is erosion. Okay, we talk about the gradient being a bit steeper. Okay, and then the velocity, high velocity of water. Then when we talk about the inner bend, what do we expect? Gentle gradient. Here you expect a gentle gradient. Okay, you expect aspects of deposition, slow flowing water, and then less velocity, meaning that the inside bend expect slip off as a slope, and therefore there is slow flowing water, more deposition. Okay, and the outer bend, which we said it's an undercut, that's where we have water flowing faster, and we expect the erosion to take place. The area is a bit steeper, that's why water is flowing faster, and that fast flowing determines also the velocity. Okay, so that is what we refer to as meandering or a meander. So a meander is a landform. Meandering is a process through which that landform of a meander is formed. Okay, so when we check somewhere here, we can still see another feature. Which feature is this one here? The feature that we are seeing here in this area is what we call a braided stream. What is a braided stream? This is a depositional feature. It's a depositional feature that forms when the materials are deposited in the river channel, okay? Meaning that since the river is in its last stage, it means it has got less power to erode, okay? So if it has got less power to erode, that means it dodges the material and later reconnects. That's why you see this river is flowing like this. So this one rejoins, this one rejoins, and then the river keep on flowing to another destination. Okay. Now, that is what we call a braided stream. So the area that is adjacent to the river, this part here, is what we call a flood plain. Okay, is what we call a flood plain. So learners, you can be in position to interpret those aspects. You can see that somewhere here is flat. That's why you see the area has got even the marsh and fay, because the area is flat. It's having a lot of water that is sitting in that area. Okay. Remember, learners, don't forget, we are still looking at interpretation. And I am trying to put all the topics in the geography syllabus all together so that we can see how can each concept or how can the concepts be applied on what? On the map. Okay. If you see anything that you're not understanding, please feel free to ask questions or to leave a comment. I'll be in position to answer you. Okay, but in preparation for exams, please take note of everything and let us try to pass. Okay, now besides this, there are some other interpretation concepts that can be applied. Take an example. There is this area here that is a bit far away from the residential areas. Okay, this area has got very big buildings. It has got even the silos. What do silos do? Those are the ones they use to store agricultural products or food. Okay, now when you check here, you will find out that they are very big settlements here. They are very big buildings here. Okay, these buildings, we can term them as industrial areas. And we can, what do we remember when we're talking about the industrial areas? First of all, industrial areas are meant to be far away from the settlements because of the noise. Okay, industrial areas are meant to be in areas where the land is cheap and available, like large areas where those industries can be established. Okay, it is established close to the roads or communication lines, okay, which you can see that there is a road here that is going, there's a road, and so on, meaning that this industrial area is basically, this area is basically an industrial area, according to the interpretation of the diagram. Okay, now, I want us to proceed and keep looking at other aspects. We are still looking at interpretation, learners. I told you today, at least I want to see the interpretation part. There's another time where I handled the calculations, and I know that I finished all those calculations. If there's anything that is remaining, please let me know. I'll re-handle it. But if there's nothing, we are still moving forward, and apparently I want us to look at interpretation. And as far as interpretation is concerned, we are almost done, because we have looked at all the possible ways in which questions can be asked in relation to the different topics that we have looked at. Okay, now, here we go. We look at another area here on the map. What do we see? Do you see somewhere here? These are industrial areas. Okay, those are industrial areas. What do we remember? Like we mentioned above, that all those industrialized areas will be built, first of all, next to the major communication lines. Take an example here. There's a road here, 102. There's another one here. There is a railway line there. There actually a lot of railway lines there. Okay, so these are industrial built-up areas, meaning that such industries discourage people to settle close to them because of the noise they make, the noise pollution. So people are staying basically far away from those industries. The reason why they are close to the main road is mainly because they need to transport, easy transportation of raw materials from one point to another, and then the finished goods. Okay. So we can have a lot of factors. For example, some of the questions they can ask here, like explain maybe, or give, or discuss, or whatever, 2 factors that have contributed to the location of those industries wherever they are. Okay, maybe the industries in Strundali. So what do we look at? We look at aspects like, for example, flat land. And you can see the area is flat because the contour lines are not so close to each other. Okay, that is number 1. Then the very big space available. The very big space available, okay, for the expansion of industries. Okay, then we also talk about the proximity or the closeness to the main roads. Okay, the existence of the main roads, the existence of the main roads. All right, the existence of the main roads. So those questions can be asked, that what are the factors that have contributed to the location of these industries wherever they are? Number 1, they are far away from people. They need a flat area. They are far away from people. They need a very flat area, accessibility, the roads, closeness to the water bodies or to the water for easy access to water. You understand? Close to other residential AO. We are saying that they must be far away from people because it makes noise. Then the road, the flat area, the cheap land, a very large space for their expansion. Okay, and therefore we also talk about the capital that is basically needed from the nearby people, or the cheap labor that they can easily access. So you can see that here is basically a developed area. Okay, it's more of a well-developed area here. Then here is an industrial area. What do we notice here? that industrial areas are located on the outskirts of the city, far away from the people, okay? And it is exactly depicted here. You can see these are settlements around here. This is a developed town or a well-structured town. And then you can see that the settlements or the industries are a bit far away from people. Okay, now, those are some of the aspects, and we can talk about there. Okay, now, I've already talked about these aspects of conservation, the aspects of conservation and the flow of rivers. Maybe here, after seeing this, I've remembered, here we can tell another way we can tell the direction of the river is by looking at the angle at which the tributaries are joining the main river. Now let's check here. This one is joining this one like this, so it is flowing to that extreme end. This one is joining like this, okay, so it is flowing this way. You can see the way at which angles are joining. The rivers are joining others. You can see this one is joining this one, and then it flows downwards, meaning that these rivers are flowing towards this other main river. And when you look at this nature of the river, there's another river there. So how does this river flow? How is it flowing? You can see it's basically flowing towards that direction. So it's flowing towards this direction. Okay. So the angles, you look at the V, determines the direction to which the river is flowing to. Maybe another concept that we can apply here is the concept of the stream ordering. When we look at stream ordering, we look at the independent streams. For example, 1 and 1, it makes 2, 1 and 1, it makes 2, 1 and 1, it makes 2. In other words, these are all second stream orders, but we shall understand that clearly when you look at another clear diagram. Okay, now when you check here, you can see other symbols. Now, if you do not know what the symbol means, this is the right time for you to know. If you still don't understand what this symbol means, what this one means, what this one means, and so on and so forth. So you must, now this is when you look at this symbol, you go to the map, and then check, okay? And then you check, and then you will understand that this symbol means this one means this, and this one means this, okay? All right, now, this is another map that is trying to give us another clear view of the interpretation. You check that, you see that this river Groti here, this river is flowing in this kind of shape. So in this kind of shape, we call it what? What we call a meandering river. So when you check this river is meandering. So this one, if you remember the meandering process, say this is the curving and the bending of river. It happens in the lower section, or when the gradient is a bit gradual or flatter. And when you check here, this kind of gradient is the same, you see? So this river is flowing, curving and bending like that. Remember, inside one is slip off, outside is undercut. So we said outside is steep slope, inside is a gentle slope. You can even see here, the nature of the contour lines out here is basically depicting a steeper area compared to what is inside here. So that is application of another concept. Now that this is now trying to assist us to get to know more other maps. How can it appear? Please, Nana has been positioned to tell how it appears. Okay. If you remember in your settlement, you must have looked at this kind of a settlement pattern. Okay, this is what you call a radio settlement pattern, a radio street pattern. Okay, radio means when the roads are radiating or connecting towards one central place. Okay, if you check here, this is a road, this is a road, this is a road, this is a road, basically a cobweb. Okay, it forms this kind of cobweb. So this kind of settlement, or the nature of the streets, the way they lay, is determined by the main roads that are connecting the main central place. So here is a central place, which is going to be our now CBD, that is having many openings of the roads from the nearby surrounding area. So those roads are all connecting towards the one central place. Okay, so this one forms what you call a cobweb kind of settlement or street pattern. Okay, other activities, other interpretation that we can look at for the mine dump, you can see the pier, you can see the roads, okay? You can see the roads here, okay? You can see the development of the town, you can see mining taking place around here, you can see drive-in theater, meaning that there is entertainment taking place. So in other words, there are a lot of things that we can interpret on the map. There is a mining museum, which now indicates that if it's a museum, it's basically promoting culture there. Okay, and then here is what we call a big hole Kimberley mine. That means there's mining taking place, or there was mining that was taking place there. Okay, so basically this is a mining town. If you remember very well what we talked about in settlement, maybe with your teachers, is what we call a specialized town, basically doing one activity. For example, mining town, okay, and this way, so an example of the mining town, to say so, because around here it's basically surrounded by mining only as the main activity. Okay, now we still look at other aspects here. Okay, remember, learners, it is nothing like I'm trying to, it's not that I'm trying to repeat these aspects, but I'm trying to show you that on different maps, if they bring you any map from any area, you can be in a position to interpret. First, orientate the map. When you're given the map, check nicely. And then before you even check the questions, think of the possible kind of questions that can be asked. Okay, so the possible kind of questions that can be asked depend on maybe how the map is. Okay, so if you orientate the map nicely, you'll be in position to figure out the kind of the possible questions that can be asked in that case. So learners, these are kind of the things that you're looking at. Okay, so here is a arterial route here, R64, that is cutting through this place. There is a Diamond Park, there is a Carter's Claim. Okay, those are just towns, the sewage dams. That means there is a, if you remember about this, if you see sewage and the cemetery in terms of the arrangement of the city, which kind of land use is that? Okay? Which kind of land use? You can see the park there, there is a park there, there is a cemetery, there is a sewage works there somewhere, a sewage dam somewhere, recreation, racetrack, you can see all that. So this is an example, or this is giving you an example that this one is a transition zone, okay, whereby these activities are basically taking place that way. So you know, sewage is always far away from people because of the smell it gives. This one requires very big space. The cemetery, this is a racing track. It also requires a flat area and a bit far away from people. So in this case, you get to know that if you are interpreting, they can also ask such questions. Identify the land use in a certain block. Let me say C1 or P.1 or C2. Remember, it will be visible on the map. So in this case, you look at the possible activities taking place. If it's a central place, or if a CBD, which is, it must be lying in the center. So if it's a CBD, it must be lying in the center, number one. If it's a CBD, it must be connected by other routes towards that central place that is connecting to it. Okay, then the developments that are going to be taking place around it. Then we have a transition zone. We have rural urban fringe. Okay, the rural urban fringe. We have the rural areas. Actually, this one should be rural urban fringe. Okay, rural urban, not a transition zone, sorry, a rural urban fringe, because a transition zone is the area that has got mixed functions. Some houses appear to be of a township area or of a township character. Some other houses are tall, some other houses are short. So mixed function is taking place there. and no transition zone will have a lot of that kind of art there, shading on the walls and all that and so on. So in this case, sorry for that, this area here, the land use around this town here, it should be a rural urban fringe. So learners, I want you to note that when they talk about rural urban fringe, please remember, you must know that the area should have at least any of these activities. Number one, sewage terms, sewage works, a cemetery, a golf course, a landing site, a race track. All those kind of activities are taking place in the area that we call a rural urban fringe. Okay. Now, which is the dominant activity taking place here? If you look at it, if you look at it, what do you think should be the dominant activity? Okay, there are a lot of reservoirs, there are a lot of furrows, okay, which is basically transporting water, row of trees. You can see the row of trees that are built around the water areas. What does that mean and what does it imply? You know, trees provide shades to the crops. That's number one. Okay, trees helps to shield the crops from the very strong winds that are likely to affect the crops on the farm. So if you see the row of trees, think of the advantages. If it's around the crops, what could be the advantages? Okay. And now when you check this area, you can see it's a bit flatter. That means it can easily favor agriculture. And the flat area also favors easy flow of the drainage systems, the rivers and the water when they want to irrigate this area around here or the crops around there. Okay, there are a lot of reservoirs, there are a lot of furrows. So when you look at this area, you can see that this is dominantly an agricultural settlement where agriculture is mainly being practiced. Okay. Now you check another area here, it's a bit flatter. So it's a low-lying area. And what do you expect? There are a lot of roads that are connected there. Okay. And then there are a lot of what you call seasonal rivers. You look at this. Maybe I also forgot to mention that while looking at interpretation. When you talk about seasonal rivers, it must be a blue line, but broken line, broken dotted line. So it's going to be seasonal or non-perennial river, okay, or periodic river. So if you see it broken or dotted line, just know it's non-perennial river. If you see it, let me check, compare it with another one that is maybe you look at this one. When you check this river here, it's giving us an example of what we call a permanent river. What are permanent rivers? Those are rivers that are flowing throughout the year where the riverbed is always under the water table, both during the dry season and the wet season. So meaning that the relationship between the water table and the riverbed is always, the water table is always above. So this river will be flowing throughout the year. So that river, how do you identify it on the map? You identify it on the map if you see it with the blue line that is continuously existing. Take an example. If this was blue like that, it's going to indicate what we call a permanent river. But if it's a broken line, like this one, blue but broken line, we call it seasonal river or non-perennial river. So such areas are having such non-perennial rivers. Okay. And the last thing that I want us to look at is this part here on the map. This part here, you can see in terms of its gradient, it is a very flat area. Depending on the nature of the contour lines, you can easily see them. You can even see the way the water is existing. Like there are a lot of several pockets of water that is colonized within one area. And that means that area is a bit flatter. So hope learners, I have not left out anything related to interpretation. So please be in position to tell in summary or in a nutshell, be in position to tell how all the topics you have looked at, both in paper 1 and paper 2, how can they be applied on the map? Everything that you look at is very, very, very important. It's very, very important in order to apply it on the map. If there is anything that I have not interpreted for you, please be in position to leave your comment, be in position to to let us know that you really need that aspect, and we shall be in position to handle it nicely. Okay, but all in all, that is what I wanted to show you regarding interpretation. That's what I wanted to reflect to you in relation to interpretation, and all is done nicely. Thank you so much. Thank you for listening, and thank you for watching. See you.
Okay, good day, learners. Good Fritz here again. Today, I want to look at the topics that we look at in term one. In term one, we look at climatology, and we focus on topics like mid-latitude cyclone, tropical cyclone, anticyclones, and so on and so forth. So for the focus of today, I want us to look at mid-latitude cyclone, and just a few aspects that I'm going to remind you. I know I've done this before, but I'm going to remind you of some aspects before I proceed. And in this process, I'm going to do this while I am giving you some kind of questions. So we shall do it in form of question format. But what I'm going to do, I'm just going to remind you a few aspects, and I'll just outline them here. First of all, in this case, we need to know what, when you talk about what, we are referring to the definition now, the definition of mid-latitude cyclone. So we start with what, okay, where, when, okay, and then we can also ask or answer why, okay. So in this case, when we say what, if we are referring to mid-latitude cyclone, we define it and we say it's a low pressure system, as you know it very well, the low pressure system, that is influenced by the polar easterlies, and the subtropical westerlies. So when you look at these two winds, these are very important. Where do they occur? They occur at the subpolar front or at the subpolar low, and it results into the formation of the polar front. Okay. So by looking at this, we ask, what is it? Okay? And by you understanding what is it, then we're looking at a definition. Where does it occur? Then we all know that it occurs between 30 to 60 degrees latitudinally, that is north and south of the equator. Okay. It occurs between 30 and 60 degrees, both north and south of the equator. And this is where we have the Ferrel cell. Okay. When does it occur? We know that a mid-latitude cyclone occurs throughout the year, okay, throughout the year, but it affects South Africa, it affects SA only during winter time, okay, it's only during winter time. So there we have answered, when does it occur? And why is it occurred, or why is it affecting South Africa during winter time? We know that in this case, we look at the fact that the ITCZ moves with the apparent movement of the sun. And you know that when the ITCZ moves further north, it simply means that it will be winter in the south. Okay, and that means because the MLCs or the anticyclone, they move with the ITCZ, that means it will move also further north in order to move with the ITCZ. And as that happens, that is when it will be affecting South Africa. And you know that you looked at the characteristics of mid-latitude cyclone, aspects like it occurs in families, you know, we talk about its movement and we say it moves from west to east. In other words, it is eastward movement. You also know that mid-latitude cyclone, it occurs in series. Those are families. We also know that mid-latitude cyclone is influenced by those two air masses, the polar front, the polar easterlies and the subtropical westerlies. Okay. Then we also know that it has got the cold sector, it has warm sector, you know, yeah, and so on and so forth. There are a lot of characteristics that we need to look at. Okay, this is just a reminder. Remember, I said that I need to remind you of these aspects before we proceed to looking at our questions. So you don't need, you also remember that you must have looked at the conditions that are necessary for the formation of tropical cyclone. First of all, we have what we call temperature differences. Temperature differences, you know very well that these temperature differences is also in the air masses. Okay, remember, one air mass is cold, another air mass is warm. So the polar easterlies is the cold air mass, and the subtropical westerlies is the warm air mass. That is one condition. And we also know that there must be the existence of the high pressure. Remember, when you look at its area of formation, we have high pressure in the north, also have high pressure somewhere there. This way, we have the subtropical high, and we also have the polar high and the subtropical high. So we know about the high pressure, that in the high pressure, air rotates anti-clockwise, okay? And then we also know that in the high pressure, air diverges onto the surface of the earth, meaning to say, if it diverges from the other side, and this one is also diverging from this other side, it will be in position to meet where? It will be in position to meet here at the subpolar low, which we know as the polar front. And because they are moving in different direction, it starts what we call the initial stage. Okay, so we looked at those conditions. We looked at the effect of a tropical cyclone on the environment, on people, and so on and so forth. So having seen all that, okay, and having reminded ourselves of those aspects, now we need to proceed and look at the questions that we have here, okay? We need to proceed and look at the questions that we have here. I told you that I've told this several times, so now I want us to make sure that we learn how we can handle different questions and how can we answer those different questions that might come on our way. So I got this question from one of the past papers in the previous years, okay? And this question is in form of a synoptic weather map that is related to a mid-latitude cyclone. When you look at it, remember in geography, when you're given a question, you don't need to rush and look at the questions that are given. You need to look at the diagram first, which we know as the annexure. Thereafter, you might find that by interpreting the diagram very well or the annexure very well, you might be answering some questions indirectly. So by the time you reach the questions, you already know what is about the diagram. So here we look at the mid-latitude cyclone, and here we have South Africa, okay? So we have South Africa here. There is a low pressure here at the coast, and I think learners, you haven't maybe looked at this clearly, or you haven't reached there, but it's called a coastal low because it is at the coast. Okay, then we have a cold front here, and we have got a warm front there. So we have got a low pressure that is well developed here, which is below 992 hectopascal. Then they have given us the date. You can see 25 of August 2020. Okay. Now, when you look at this, it's a high pressure here, and this one is appearing like that. So what do we need to do? We need to look at now the kind of questions that are being asked. Okay. When you check your question, they say, figure 1.3 shows mid-latitude cyclone on a synoptic weather map of South Africa. Then you come here, you can see it's a mid-latitude cyclone because of the cold front and the warm front that is visible there, and it is moving from this side to the side, and it is approaching Western Cape. Okay, so it's a cold front that is affecting South Africa. Like I told you that you can already see the sketch of South Africa. The first question that comes our way is saying, okay, the first question that we have on our way is saying, give evidence from the diagram. Give evidence from the diagram. You can see the questions. I want to read it as many times as possible so that you can understand what the question requires. Okay, they say, give evidence from the diagram that suggests that weather system A is a mid-latitude cyclone. What evidence do we have that suggests that weather system A is a mid-latitude cyclone? We go back to the system. The system is here. What evidence do you see from here? A is here. And there's a cold front here, there's a warm front. What evidence do you see that this is really a cold, a mid-latitude cyclone? Hope you understand. You can see learners here. So you can see the cold front. Can you see it? This is a cold front. Okay. And the moment we talk about mid-latitude cyclone, automatically what should come in your head is a cold front and a warm front. So the first evidence that we have here is that the cold front and there is a warm front here. You can see the symbols. It's a cold front and a warm front. Therefore, that is evidence number one. So evidence number one is that cold front and warm front are clearly visible. That is evidence number one. You can easily see the cold front and the warm front. Okay? That is evidence number one. Evidence number two, when you look at this line here, can you see on this line, we have got this symbol here and this symbol, which tells us obviously that this low pressure has reached its occlusion stage. And when you remember, if you remember from your books, we talked about the stages of development, and we mentioned that the first stage is the initial stage. Second stage is what? The development stage, okay, or the wave stage. Then we also have the mature stage, okay. We also have the occlusion stage, okay, occlusion stage. Then you also have the dissipating stage, okay. And when you talk about the stages, initial stage, you know that air is just moving in the opposite direction. Development stage, a wave develops, okay, and a kink starts to come up, okay, that is development stage. Then you know that when you talk about mature stage, clearly the cold front and the warm front can be clearly visible. When you talk about occlusion stage, you remember that the two symbols of the cold and the warm front appears on the same line. Why is it so? It's because the cold front or the cold air moves faster than the warm air, and it catches up with the cold front, which catches up with the warm front, which results into the development of the occlusion stage. And the dissipating stage, you know that the pressure starts to go high. So the moment you remember that, you will see that somewhere here, if you can see it clearly, somewhere here, we have the cold sector here. I mean, the cold symbol, the cold front symbol, and the warm front symbol almost sitting on the same line, which indicates that that is clearly occlusion stage. Okay. Besides that, you also know that we must have discussed this with you learners, or you must be remembering this, that behind the cold front, there is a cold sector, and behind the warm front, there is a warm sector, which simply means that the whole of this sector here, coming this other side, is cold sector, even if it is not named, but you can know. And the whole of this sector here is warm what? Warm sector. If you remember that evidence also, you can clearly tell the examiner that the cold sector and the warm sector are also existing. Okay, they are also existing. All right. Then besides that, you remember that the system moves from west to east. And when you look at where the cold front is, the cold front is somewhere here on the western side. Maybe it is, that simply means it is proceeding towards this side. And remember we said when you're looking at the characteristics that they move from west to east. Why? Because it is part of the westerly belt. Among other characteristics, you can talk about the date, which clearly indicates that it's winter date because August is not yet summer. Okay, it clearly indicates that we are still in winter time. Okay, so the date indicates that it is a cold front. There are very many things that you can look at. Okay, so you can even look at the rotation. Air rotates anti-clockwise within here, though it's not actually the the air rotates clockwise within the cold front, the mid-latitude cyclone. However, even in tropical cyclone, it rotates clockwise. Therefore, that one, I will definitely say it won't work here. We need the evidence that indicates that this one is truly a mid-latitude cyclone, which is what is unique with it. Don't look at this, what happens with it and also happens with tropical cyclone. It does not give a clear picture of what we want. Hope you understand that. Okay. We'll go ahead and look at question 2. It's a 1 question mark, but I'm taking a little bit of more time because I'm trying to expand and explain more and more, such that in case another question comes and it is on one of the things that I've handled or that I've tackled here, then I definitely know that you won't struggle to answer those questions. Okay. We go to question number 2, 1.3.2. 1.3.2 in says that why does this weather system originate at the polar front? Why is it that, or why does this weather system originate at the polar front? Okay. They are asking, why do you think? We go back to the diagram. Maybe you can clearly get it. Why do you think this system originates at the polar front? Okay. Okay. I hope you understand the question. Why does this weather system originate at the polar front? You know, front is the point where the two air masses of different characteristics do what? Do converge. I think I'm even telling you the answer before. Yeah, I even reached there. They have even given, you can use reasoning and get the answer there. Here, you're saying, why is it originating at why is the system originate at the polar front? But somewhere here, they have talked about a front. Okay, it's here, and they have talked about a front. What do we know about a front? A front, obviously, is where two air masses of different characteristics do what? Do meet or converge. So first of all, why does this weather system originate at the polar front? One of the reasons could be that it's because of convergence of the cold, dry air, which is the polar easterlies, and the warm, moist subtropical air, which is the westerlies. Where do they converge? They converge at the polar front or the subtropical region. That is why it originates from there. Okay. I hope that is very clear, learners. Okay. Then the second question, question number 3, it says, give a reason for the direction of the movement of this weather system. Okay. Give a reason for the direction of movement of this weather system. First of all, when I was starting to explain about the mid-latitude cyclone, I hinted on all these ones. I even indicated here that it moves from west to east. And I also gave a reason. You see, learners, why it is very important for you to first study the diagram critically, understand the diagram very well, try to answer it before you see the questions, and that will help you to ease your work when you try to answer the questions. Okay, so we go back and see that you give a reason for the direction. Number one, it's how many marks? By the way, learners, it's very important to look at the mark allocation. Number one, that it is driven by the westerly winds. Westerly winds. If I must remind you of this, you remember, if you remember, you would have drawn something like this. Sorry. And then when you divide it like so, this is the equator. Somewhere here, we have what we call the 30, and somewhere here, we have the 60. Then at the end here, we have the 90. Okay, sorry about my pen. So here is where we have the westerly belt. Winds move from west to east. You see that? So if winds are moving this way and the system is within here, automatically that system is also going to be forced to move into that direction. So the reason is that it is being driven, or it is steered by the westerly winds. However, someone can also say that because of its location, look at its location, this belt here is within the westerly belt. This is what we call the westerly belt here. Okay, if this is the westerly belt, how are the winds moving in the westerly belt? They move from east to west, meaning that whatever is here, it's like you sitting in a bus that is going in the west, in the easterly direction or eastward. Automatically, even you who's in that bus, you will go in the same direction where the bus is going. So one of the reasons that you're going to give here is because it is located in the westerly belt. Okay, it is located in the westerly belt. So those are reasons. It is driven by the westerly winds, or it's located in the westerly belt. You can choose any that is answering these questions. Okay, I want to teach my learners nicely and ensure that you get very good marks. So I want you to understand clearly. If there is anything that you're not understanding, please feel free to come in the inbox, ask questions. We'll definitely assist you. We'll definitely answer those questions. All right, we go to the next question. The next question, that is 1.3.4. 1.3.4 is saying, why is the cold front associated with severe weather condition? They're talking about the cold front, and they're associating the cold front with what? The severe weather conditions. You see that? You see this cold front and the severe weather condition. Why? Why means give reasons. Don't forget the mark allocation. It's 1 times 2. That means it is 1 point. Okay. They're saying, why do you think the cold front? We can quickly go back to the diagram and see which one is the cold front. The cold front is here. But what do we know about this cold front? We all know that warm air from this other side rises or ascends in the upper atmosphere along the cold front, and it results into the development of what we call the CB clouds, or the cumulonimbus clouds, which we know that these cumulonimbus clouds are associated with the heavy rainfall, okay? Heavy rainfall, thunder and lightning, okay? And so on and so forth. Those are kind of, when you look at that, you're going to see that here, that means along the cold front here, you expect heavy rainfall. That is one of the severe weather conditions. You expect thunders. That's another severe weather condition. You expect lightning. That is another severe weather condition. And so on and so forth. So, under that reason, we need to understand, the question is asking, why do you think it has got that serious weather conditions? Okay, so by me explaining those aspects before I look at the question, I've already answered the question. Okay, but I also want to answer it the way it is indicated, though, like I told you, learners, that I'm not specifically looking at the question only. I'm trying to elaborate. I'm trying to explain further about different aspects, so that in case it is exam time, you can try to remember some of those aspects that I have explained. One of the reasons that I've indicated here why it would be having severe weather condition is because of the upliftment or the uprising or the rising warm air. That is one. You know that when this warm air rises, if you remember very well in your grade 11, we said that warm air rises, and warm air is associated with the formation of cumulonimbus clouds and so on, and this is associated with unstable weather conditions. You understand? So those unstable weather conditions are clearly indicating automatically what happens along the cold front. So one of the reasons that we are going to have is that there is continuous and rapid rising of warm air along the cold front. And when it rises, it condenses, forming clouds, forming rainfall. So reason number one is the rapid and continuous rising of warm air. So we shall say continuous rising, or we shall say continuous ascending warm air along the cold front, and automatically that will disrupt the weather conditions, and therefore we shall have those severe weather conditions experienced along that cold front. That is number one. Remember, it is 1 times 2. It is 1 mark. Maybe in an exam that you might face, they might say 2 times 2. So I'm going to give you at least 2 points so that you pick up what you feel is easier for you. Okay. Or 1 or 2 or 3, any, fine. So the second reason that I can give is that, first of all, when this warm air rises, what is next? It results into the development of cumulonimbus clouds. So we shall say the development of the cumulonimbus clouds. If you remember very well in your grade 10, you looked at the cumulonimbus clouds. You mentioned some of the characteristics, like what? That cumulonimbus clouds grow very tall, okay? They develop to greater heights. They are flat-bottomed. They grow wider. They are associated with heavy rainfall and so on and so forth. Automatically, because of the excess of cumulonimbus clouds along the cold front, you expect resultant effects of what? Heavy rainfall, okay? Lightning and thunder. All those ones are conditions that are known as severe weather conditions that will be experienced along the cold front. Therefore, we say because of the prevalence of or the existence of the cumulonimbus cloud, automatically it will result into the severe weather conditions along the cold front. Okay, and you also know that along that line there is also what you call the backing of winds. What is backing? Backing is the change in the direction of winds. So we know that because there is continuous rising of warm air, it results into the winds to change directions. And when these winds change direction in the southern hemisphere, we call it what? Backing. Okay, so that is another reason why we shall have the severe weather condition, because the winds would have changed direction. So there will be disruptions along the coast or in the way as they are being formed. All right, we'll go ahead and look at another question. The next question is 1.3.5. Don't forget the mark allocation. They're saying 1, but I give many because I want you to be in position to get as many points as possible, in that if a question comes and it is 2 times 2, you still don't stress. You have marks to give. Okay. The next one, they say, explain the formation of the stage of development shown in figure 1.3 of the mid-latitude cyclone. Explain the formation. So there we look at what the question requires. The question requires explain the stage of formation. In which stage is it of the MLCs? We're looking at the stages of formation. What are the stages? Remember, I outlined the stages when explaining about mid-latitude cyclone, okay? But now when you look at the diagram, do you think that this one is, do you think that, is it an initial stage, a development stage, a mature stage, occlusion stage, or dissipating stage? Let us try to remember some of the characteristics that are there. Initial stage, the pressure is still high. Is this above 1,000 hectopascal? Is this high above 1,000 hectopascal? No. So that means initial stage is out. We look at the development stage. Development stage, we say the pressure starts to drop and a wave develops. That means a wave develops, and that clearly means that the cold front and the warm front are not yet clearly formed, but here they are clearly formed. Therefore, we also take out the development stage. What are we remaining with? We are remaining with the mature stage, occlusion stage, and dissipating stage. And then when you look at the diagram, we have another characteristic, which we know that, another stage which we know is a mature stage. And when we talk about mature stage, we know that the pressure drops further or drops down. When it drops down, the cold front and the warm fronts are well developed, okay? And if they are well developed, the gradient is very steep, and so on and so forth. But is it that stage of mature? I would say it's not a mature stage, despite the fact that we can see the cold front and the warm front. Why? Because somewhere here along the same line, we have the cold front and the warm front sitting on the same line. Those two symbols, if they're sitting on the same line, we quickly say it is occlusion stage. Automatically, it's not dissipating stage because the pressure has dropped further here. Okay, so this simply means that it's not a mature stage, it is occlusion stage. So the moment you understand that, oh, it's occlusion, sharp, what next? You remember about the occlusion stage. There are things we need to mention about occlusion stage. Like what? The cold air moves faster than the warm air. It catches up with the warm air and it starts eating up the sector that was occupied by the warm air, pushing the warm air outside the cyclone. And this results into the development of what we call the warm occlusion and the cold occlusion. Okay, so the moment we talk about those aspects, guys, you can understand. Okay, you can understand what I mean. So under that line, we understand that this is occlusion stage. So we need to know, if we say that it's occlusion stage, we go back to the question. Let's see the question. That was the first thing that I wanted us to know. So if it is occlusion stage, what do we need to know? Occlusion stage, we need to understand that because they are saying explain the formation of the stage, so we need to explain how this stage forms. Okay, the first thing first, we are going to mention about number one, cold air moves faster than warm air. Okay, cold air moves faster than warm air. So if cold air is moving faster than warm air, okay, what happens? We can explain the second point. We are going to find out that if cold air is moving faster than warm air, so warm air catches up with, it's not warm air. Cold air catches up with warm air, narrowing the space that was occupied by the warm sector. Okay, pushing it outside the what? The cyclone. What does it mean? You'll find out that if this is the cold sector, and this is the warm, the cold front, and this is the warm front. This one is moving faster. That means it is catching up with the warm sector. And the warm sector has got the warm air, so it's pushing the warm air outside the cyclone. Do you see that along this front we shall develop two symbols because there is a warm, cold front and the warm front that is developing along the same line. Therefore, we shall come up with what we call the occluded stage or the occluded front along this line. So we are going to say that warm air moves faster. I mean, cold air moves faster than the warm air. And when cold air moves faster than the warm air, so that means the cold air is going to catch up with the cold air is going to catch up with the warm air, narrowing the warm sector, pushing the cold air, pushing the warm air outside the what? Outside the cyclone. Okay. You understand? And therefore, when it pushes it outside the cyclone, what will happen? Simply means that at the apex, okay, at the apex, the cold front, the occlusion front is going to do what? It's going to develop. And when it develops, obviously, we are explaining the occlusion stage. And therefore, you'll get all your marks along that line. Okay. We look at the next question. We look at the next question. The next question, sorry for that. The next question says, why? See, you know, I read as many times as possible. Why? Why does the cold front of the mid-latitude cyclone have a positive impact? The question is asked, why? Give reasons. Why does the cold front of the mid-latitude cyclone have positive impact? Positive. The question is one-sided. Positive impact on agricultural activities in Western Cape. Positive. We are focusing on positives only. And the question is asking why. That means we are basically going to give the reasons as to why we shall have a positive impact on the other side. Okay. Okay. We're talking about the cold front. What do we know about the cold front? We know that the cold front, number one, it is associated with heavy rainfall. And how will this be important? Heavy rainfall will fill up the dams, okay, that they will use to water. In case of a dry period, they will use this to water the farms. And if they water the farms, it obviously means that the agricultural activity has got a positive impact. So do you see the reason why? The reason is why do we have such? Because we shall have heavy rainfall that is associated with the cold front. Remember, the question is asking why. So since the question is asking why, that means you need to give reasons why we shall have a positive impact. One reason is that this cold front has got heavy rainfall. So because it has got heavy rainfall, this heavy rainfall will be very important. How? It will be important in many ways. Number one, it will fill the dams. Number two, it will make the rivers full. Okay, that means the rivers will have water. Number three, besides the rivers having water, people might have their tanks, like JoJo tanks, that will also be full. But in case of anything, they will need to use water and there is no rainfall. They can easily have access from the dams, from the JoJo tanks, from the rivers, and that will assist them to water crops. And by watering crops, it simply means that there will be a positive impact on agriculture in Western Cape. Okay, that is number one. Reason number two that we can give, we can also say that because of rainfall still, people will be in position to water their crops. The first reason was they will be in position to have water in the dams that they will use in the later stage. The second reason is that besides them having water to use, they will have water to irrigate the crops. And by them having water to irrigate the crops, it simply means agricultural activities are going to benefit. See that? So the agriculture sector will benefit because there will be enough water that will be used in the watering of the crops. When we talk about watering, we are basically referring to irrigating of the crops. Okay, I think you see how the agricultural activities are benefiting from the cold front, okay, in Western Cape. We also look at the fact that the agricultural activities in Western Cape are also going to benefit. How? In the same line that if water is available, crops will grow. What will happen? That means agro-based industries are going to benefit as well in Western Cape because there will be continuous supply of agricultural crops that will be used as a raw material in the agro-based industries in Western Cape. You see how the agricultural activities are now being assisted, or how these people are benefiting from that aspect. We also look at another aspect. We can give as many points as possible. We know that we all irrigate crops, or besides that, we can use pesticides, we can use insecticides to kill insects that are affecting crops. That means the soils will have those kind of chemicals that are remaining within that region. But when it rains from the cold front, we shall have enough rainfall, and this rainfall will wash away all those toxic toxic materials or elements that would have affected agriculture in the long run. And you see that the agriculture activity is now benefiting. So that means it cleans the polluted rivers, or it cleans the polluted environment. And that means even the water that is going to come to the agricultural products, or to the agricultural to the crops, is going to be clean water. Why? Because the cold front has got rainfall. You see how this is very important. You see how that is very important. We can also look at it in a positive way, that when it rains, it results into flooding. But what is important with flooding? Flooding will mean that some topsoil will be eroded and deposited somewhere. And maybe that soil that is deposited somewhere can be used for agriculture. Do you see that? So it simply means that soil fertility will be improved under that line. So improving soil fertility, how is it important? This will assist in favoring the growing of crops in Western Cape. And how is it coming about? It comes about because when it rains, flooding will take place, fertile soils will be deposited somewhere that can be used by agriculturists to benefit. Okay, do you understand that? I hope you understand. I hope we are all at the same page. Okay, so besides, when you're talking about agriculture, I don't want you learners to be one-sided. Agriculture simply means the growing of crops, rearing of animals, and poultry. When you talk about when you talk about crops, that means you're looking at basically arable farming. Then you talk about animals, that is livestock. Then you talk about the keeping of birds, okay, that is poultry now, keeping of birds and so on. So don't be one-sided, only looking at the crops. You can also look at animals. How do animals benefit? That when it rains, the grass will grow for animals to survive on. That is benefiting agricultural activities. Besides that, when it rains, water will be available that will be used to feed the or to drink by the animals. Do you see that when animals are now also benefiting under that line, it is assisting what we call it will be assisting the agricultural activities, and which is what we call the positive impact on agricultural activities. You understand that? I hope it is very clear. I think it is very, very clear, learners. So at least today, I managed to go through that question of mid-latitude cyclone. Okay. Next time, I'll also pose another question of tropical cyclone, and we see how we can answer also that question. Because at least if I can do one, and in that case, I finish that one, and you understand it clearly, then it will be okay. If not, I can also pose another question. I can bring another question regarding Mid-Latitude cyclone. So you will find out that most of these questions are almost the same. Okay, so this will assist you to know that, oh, there's no very big difference. So if you understand your question nicely, you won't face any challenges. Okay, I want to look at this question here. I want to look at this question here, which is 2.1, 2.3, figure 2.3. Okay, let me check with the annexed learners so that we can see what 2.3 is talking about. Okay, 2.3 is there. Let us look at this diagram, 2.3. Remember, I told you that we don't need to go and read the questions first. We need to, first of all, understand, study the diagram. That's why they say refer to figure. Reason why they say refer to figure A, figure B, 1.2, 1.3. They're trying to make sure that you study the diagram nicely. Hope you can see this diagram, learners. When you look at it, it says 2 stages of development of mid-latitude cyclone. What do you see? We see there is this stage and there is this stage. They are saying 2 stages. By saying 2 stages here, né? By saying 2 stages here, that means you are going to see which stage is it. You remember when you're looking at stages, we said that we can have a cold front and a warm front existing, but it does not necessarily mean that it's a mature stage or occlusion stage. We need to look at other critical things. So when you look at this one, at the pressure has dropped further. We are now studying the diagram. The pressure has dropped below 998 hectopascal. Okay, but when you look at this one, the pressure is 1,000. That means somewhere above this stage, it's not the same like here. So what do we see? We can see a well-developed warm sector, a well-developed cold sector, a well-developed cold front, a well-developed warm front. The pressure has dropped further. The spinning of the wind around the low pressure is clockwise. Okay, so this is southern hemisphere. And when you look at this stage, it clearly indicates that A is a mature stage. That is obvious. When you come to this, you would see that, yes, there is a warm sector, it is a cold sector, but along this line here, there are 2 symbols existing. And what did I tell you? That if you have 2 symbols sitting on the same line, it clearly indicates that it's an occluded front. And this is occlusion stage. Okay, so and you can see that within the occlusion stage, the pressure starts to rise again. Do you understand that, learners? So when you study this diagram, you will know that at least stage A is mature, stage B is occlusion. Okay, before you look at the questions, you have already answered the questions before you even see them. Do you understand that? This makes geography very interesting. Let's see the questions now. Okay. Figure 2.3, which shows 2 stages in the development of a mid-latitude cyclone. Okay, 2.31, it says, state the hemisphere. Is it north or south in which the mid-latitude cyclone is developed? What do we look at to say whether it's south? And you remember, I even answered that question before I could see the questions, because I told you that if you see you see the symbols, the rotation here. First of all, let us look at the rotation of A. The A rotates clockwise. Okay, and if A rotates clockwise, the same here, it indicates that it is southern hemisphere. If you can remember this hint here, I told you, you draw your letter S. When you cut it into 2, you say north and south. In the northern hemisphere, you can see it's a low pressure, but it anti-clockwise. When you cross the equator, it starts moving clockwise. You see that? So this is clockwise, this is anti-clockwise. If you can remember this, you won't forget the spinning of A around the rope or into the low pressure. You won't struggle on it. So we have answered this. Which other evidence can we see that it is southern hemisphere? We look at the warm sector. Look at the warm sector. The warm sector is facing northwards. The same way here, the warm sector is facing northwards. And the cold sector is facing southwards. the cold sector is facing southwards. You remember, you also go back and remember, if you are confused, you remember this. And this is the equator, okay? This is the northern hemisphere, this is southern hemisphere. If you draw this line here, I'll name it 60 degrees. And this way, somewhere here is 30 and 90. Do you know that the air that leaves the polar front is called polar easterlies, okay? Polar easterlies. So they will be like this. So if this is polar easterly and you know it's cold, the cold sector will be in the north if it's the northern hemisphere. Come the southern hemisphere. This is 90, 60, and 30 here. What do we see? We know that somewhere here is the pole, which we know that the South Pole. And the winds that leave the southern, the pole, we call them polar winds. But because they appear to be coming from the eastern side, we call them polar easterlies. So they come from this side to this other side. Do you see that? So we call them polar what? Polar easterlies. So if you look at this, if this side at the bottom here is where we have the cold air concentrating, it indicates that it is cold sector in the south. So cold air is in the south. You can see that means the cold sector is going to be in the south. You can see it. And here we shall have the subtropical westerlies or the westerly winds that are in the north. That means the upper part is going to be warmer. So here is warm, here is warm, here is cold, which indicates that southern hemisphere. So we have as many evidences as possible that you can use to answer this question. But given the fact that they just want one answer, which is in state, whether it's north or south, when you go back and interpret the diagram, it indicates that this is the southern hemisphere. Therefore, it's south where this mid-latitude cyclone has done what? Has developed. Hope it is clear that way, learners. Okay. Let's go on and we'll look at the next question. Give reason for your answer. You see that by reading the diagram, you already have the answers. The reasons are there. We talked about the spinning of A, which is clockwise. A rotates clockwise. The warm sector is facing northwards. The cold sector is facing southwards. All these ones, the rotation of air is clockwise. All these ones are evidence that indicates that indeed this is what? Southern hemisphere. Okay. That indeed this is southern hemisphere. So let us go quickly and look at the next question because there's no further explanation that you need. Okay, so we can go put evidences there. What evidence can we have? Clockwise rotation. Remember, it is one mark. So you can use any point, clockwise rotation. Then you talk about the positioning of the cold sector and the positioning of the warm sector and the cold sector. So we say the warm sector faces northwards, the warm sector faces northwards, okay, or lies in the north. And therefore the cold sector also, for it lies in the south. Okay. You can also look at where the symbols are facing, which implies the rotation. Okay, so any evidence that you give is fine. Let us go on. Along which front does the mid-latitude cyclone develop? Along which front does? I explained this, learners. We have answered it it was in the other question. It is what you call the polar front. Okay, it's the polar front. Okay. The next question is that the one difference between the cold sector and the warm sector, just one difference. So when you are stating the difference, you make sure that it is different. What do we say? We shall say, if it's cold sector, do you expect air to be warm or cold? Automatically, it will be cold. Therefore, we shall say, cold sector, air is cold, while, remember, it's state difference, while warm sector, air is warm. That is one difference. So those are the first 2 marks. The second 2 marks, we shall say that within the cold sector, if it's cold air, what do you know about cold air? If you remember the characteristics of cold air in your grade 11, we said cold air is dense. Therefore, we shall say within the cold air, the cold sector, within the cold sector, the air is dense, heavy or heavy and dense, while here in the warm sector, it's going to be light. Okay, it will be light or less dense. Is it okay? You can also give another characteristic and you say, because here is cold air, what do we know about cold air? Cold air results into a high pressure. Therefore, we shall say within the cold sector, there is a high pressure. But within the warm sector, there will be a low pressure. You can have as many differences as you can. Okay. But those are enough for us to proceed. So let us proceed because we need to, it's just 2 marks. So you choose. But when you're giving difference, you make sure that you state it complete. Okay. It's a difference. So if here is red, then you say the other one is blue or black or whatever. So cold air, in the cold sector, air is warm. So what about the warm sector? The warm sector, air is, sorry. In the cold sector, air is cold, while in the warm sector, air is warm. That is the difference. Okay. All right. Let's go to 2.35. Describe how occlusion stage occurs. Do you see that now this question looks similar? Like this question we answered here. See, this one was saying, explain the formation of the stage of development shown in the Mid-Latitude cyclone, which we said that the stage was called, was occlusion stage. And then when you look at this question is saying, describe how occlusion stage occurs. You see that the question is now, it's just the way it is twisted, but it is the same question. It is answered the same way. How? You're going to say cold air moves faster than the warm air. Okay. Cold air moves faster than the warm air. So what happens? So the cold air wedges underneath or cuts underneath, okay, underneath the warm air, lifting it outside, wedges underneath the cold air, lifting it outside the cyclone. And what happens at the apex? Okay, we shall have the 2 symbols sitting or appearing, which results into the occlusion stage. So you can see, learners, that this is the same what? The same way the question was asked. So I won't dwell more. I won't take more time there. The last question says that explain why it is suitable for outdoor activities to take place after the occlusion stage. It says after. What does it mean? After the occlusion stage. We have just said that the occlusion stage, the pressure goes high, you know. We also know that within the mature stage, what are some of the conditions that might prevent people from having their activities outside? Okay, that now will be different from that will be different in the after the occlusion. Okay, so you look at those aspects. Why do you think we shall have outdoor activities? What do you understand, learners? We say outdoor activities, meaning that the activities that are outside, when you're outside, will it take place after the occlusion? Yes. Why? Because after the occlusion, we do not experience that kind of heavy rainfall. So that means no rainfall will be existing. Okay, no rainfall will be existing to disrupt the activities, the outdoor activities. That's why we shall have outdoor activities more pronounced or more dominant after the occlusion stage. That is number 1. Number 2, you can also say that after the occlusion stage, the weather will be stable. Remember, we say that the pressure goes high again after the occlusion stage. If the pressure goes high again, that means cold air will be existing. So the weather conditions will be stable. So we shall experience what we call stable weather conditions after the occlusion stage. And that will assist us to have outdoor activities. If the weather conditions are stable, you expect the winds to be calm, clouds to be clear, and that will favor outdoor activities. Okay. Besides that, after the occlusion, the temperatures won't be very cold, so we shall have mild temperatures. Mild temperatures existing. And when we talk about mild temperatures, we're talking about mild, meaning it's so cold, it's not so cold, it's not so hot. And those temperatures are favorable for the outdoor activities to take place. So mild temperatures will be existing, mild or moderate, okay, or moderate. So it won't be cold, it won't be hot. That will favor activities to take place, okay. What about the winds? The winds will be calm winds. So if the speed is not that rapid, it simply means if you want to put your tent outside, you want to have your braai outside, your activities will be going on very well, okay, because it's after the occlusion, the conditions are calm, and so on and so forth. Okay, I would love to stop here today, learners. Hope you have enjoyed the lesson, and I hope that you can ask questions where you're not understanding, such that we will be in position to assist you and you get everything done. Okay, so see you next time. Bye-bye.
We are going to look at the following questions based on climatology and geomorphology. I believe you are set to go. Firstly, we are doing question 1.1, which says, refer to the figure 1.1 showing a stage in the development of a mid-latitude cyclone. Choose the correct words from those given in brackets. Write only words next to the question number in the answer book. As well, you might have been told that in exams, that is an instruction where when they say you write the answer next to the question number. Therefore, let's go straight to the first question, 1.1.1, which says a mid-latitude cyclone is also known as, in brackets, coastal low pressure stroke extratropical cyclone. Let us go see the addendum. So this is our addendum, or the figure of a mid-latitude cyclone. As you can see here, we have the polar front, we have the warm westerly winds, and as well we have the cold easterly winds. Therefore, we go back to the question and we look. It says a mid-latitude cyclone is also known as a coastal low or extratropical cyclone. And for our answer, it's going to be the extratropical cyclone. Reason being, it cannot be a coastal low because we all know that coastal lows, for example, as I indicate here, these are low pressure systems that develop along the coast and they move from the west to the east along the coast. So this will be a coastal low. For our answer, it's supposed to be the extratropical cyclone. That is for question 1.1. 1.1.2, it says the mid-latitude cyclone in figure 1.1 develops, in bracket, southern stroke northern hemisphere. What could be the answer? Let us check the figure and we see. The question says that the mid-latitude cyclone does develop in the northern hemisphere or the southern hemisphere, according to this figure. As we can see here, look at the warm westerly winds and look at the cold easterly winds. If you were to examine, going back to, let us try to indicate our global winds, where this is our equator at 0 degrees, as all know. This is the south hemisphere, and we have the northern hemisphere. Now, the question is this mid-latitude cyclone situated in the north or situated in the south? But the best way to understand this question is you need to understand the movement of the winds. Let us try to indicate, to label the winds in the southern hemisphere. Let me remove these two, since now we know southern hemisphere and northern hemisphere. Now, we know that in the southern hemisphere, we're going to have our polar easterly winds, our easterly winds in that direction, and we shall have our warm westerly winds in that direction. So this is the westerly winds, and down here we have, we have the cold easterly winds. Here we have the warm westerly. Now, if you look in the northern hemisphere,
GPS signal lost.
If you look in the northern, sorry about that. If you look in the northern hemisphere, we're also going to have the westerly winds. So shall have the easterly winds. I wanted to look at the pattern of these winds. If we check in the northern hemisphere, look, this is the cold easterly winds, and this is the warm westerlies. This applies in the northern hemisphere. If we check in the southern hemisphere, look at the pattern of the warm westerly winds and the cold easterly winds. Therefore, if we check on our figure, you can see this is the westerly winds, as you can see there, and this is the easterly winds. If we compare this to this diagram here, if you look in the northern hemisphere, look at the westerly winds. They are in this other position like this, you see, and the easterly like this, which is not similar to what we see in this diagram, which means we take out that one. Let us check the one in the southern hemisphere. If you check in the southern hemisphere, look at the westerly winds, the position, the westerly winds. So if I check, this is the westerly wind, and if I check again here, this is the easterly winds, which is this one here. So which means that this MLOC, which we refer to as a mid-latitude cyclone, was situated in the southern hemisphere by the mere fact that the westerlies are situated on top and the easterlies are situated at the bottom, which is clear here. We have the warm westerlies situated on top and the cold easterlies at the bottom. And if you check on our figure, this is the warm westerlies on top and the easterlies at the bottom. So our answer then is supposed to be southern hemisphere. Question 1.1.3, it says a mid-latitude cyclone is a high or a low pressure system. What does that mean? We all know that it is being called a cyclone, and all cyclones are low pressure systems. So a mere fact that you understand that we have a cyclone and cyclone, it means that this mid-latitude cyclone is going to be a low pressure system. Hope we are clear on that. Question 1.1.4. The stage of development shown in figure 1.1 is the wave stroke mature stage. Let us check once again. If we do check on our figure once again, they're saying, is it wave or mature stage? Now, the mere fact that we all understand that a mature stage, there must be at least the visibility of a cold front and a warm front. I believe all of us know the symbol for the cold front and the symbol for the warm front. This will be typical of a mid-latitude cyclone in the mature stage. But if we check on our figure once again, we are only seeing the westerly winds and the easterly winds and the polar front, which means the cyclone or the mid-latitude cyclone, it is still developing, which means it is in its wave stage. Check again here. If we check at the polar front, you see there is a depression which has developed, which is in the form of a wave, which is also an indication that this MLC is still in the wave stage. So our answer for this will be the wave stage. Question 1.1.5, it says a mid-latitude cyclone moves in the stroke an easterly stroke westerly direction. Now, this question talks about the movement, and we all understand that movement, it refers to moving from one point to another point. In most cases, learners do confuse this question of movement with the rotation. Rotation is something, it is spiraling around, but movement, it means you are moving, for example, from, let's say, Pretoria going to Johannesburg, or from Johannesburg to Cape Town. That means there is a movement from one point to another point. So for this case, when they say movement, if I use this arrow here, now this shows that someone was moving from point A, that's point A. Let me change my handwriting here quickly. Sorry about that. So it means someone is moving. This is point A. That's point A to point B. So it means that boy to male is moving from point A going to point B. If it's like this, then they ask you, in which direction was boy to male moving to? Then it's a boy to male moved from direction A towards the point B, which is supposed to be from east to west. However, if we go back to our question after that illustration, which says in which direction? In which direction? So it's going to be the easterly direction, because we know that mid-latitude cyclones, they move from west to east. Sorry, let me change again. Yes, they move from west to east. In sometimes some question could be, they could just indicate only, they could say west to east, or it could as well be the same as from west to east or easterly direction. It means the mid-latitude cyclones, they always move from west going to the east or to the easterly direction. I believe we all understand or know why that happens, because the MLC, which I usually abbreviate, meaning a mid-latitude cyclone, they develop in the westerly winds. And the westerly winds, we all know these are global winds which move from the west, move towards the eastern direction. So if the MLC, for example, if I can illustrate it here, these are our winds, which are the westerly winds. Why do we call them westerly winds? Because they move from the west to the east. We know that winds are named from the direction where they originate. So these winds are originating from the west, going to the east. That's why they are being called the westerly winds. It is the same as, let's say you are a South African and you'd like to move or to locate to USA or to move to USA. When you go to USA, if they ask you, who are you? You're going to say, I am a South African. Why? Because you originate from South Africa. So the same apply to these winds. If the winds come from the west, these winds are going to be referred to as the westerly winds. Therefore, if we have a mid-latitude cyclone developing in these winds, for example, it means that this mid-latitude cyclone will be driven in the same direction of the winds, from the west going to the east. So that is why we say our answer was supposed to be the easterly, meaning where they are moving to the east, but they come from the west. Question number 6, it says, a mid-latitude cyclone has a greater influence in South Africa. In bracket, they put summer or winter. All of us know that these are different seasons. We have summer, where we know it is always, temperatures are always high, and in winter, temperatures are going to be low. But we all understand that mid-latitude cyclones, they don't have a specific season of development, unlike the tropical cyclones, which form only in summer. For the mid-latitude cyclones, they can as well develop in summer or in winter, provided we have the polar estuaries and the warm estuaries. That is why the mid-latitude cyclones can develop in whichever season. However, the question is asking, a mid-latitude cyclone has a greater influence in South Africa. Is it in summer or winter? And for this case, our answer is going to be winter season. Why do we say winter season? Let us try to illustrate to see if you can understand it a bit more. Let me try to create some space here, or let me try to use this blank page. So we say that they usually affect South Africa mainly in winter season. Let's try to draw a sketch map of the map of Southern Africa. We know that the pressure belts, they migrate. In summer, the pressure belts migrate further southwards. That is why in summer, we usually see the mid-latitude cyclone located far away from South Africa. So this is typical of summer season, meaning that in summer season, the pressure belts, they move further south. If they move further south, it means this results into the mid-latitude cyclone as well to shift further south away from South Africa. But if we compare this with the one in winter, this is winter. Remember, it is a sketch map. Now, winter season. winter season. In winter, we know that pressure belts, they migrate northwards, meaning we're going to see the high pressure cells moving further north, and as well the mid-latitude cyclone also moving further northwards. So you can see that in winter, due to the migration of the sun or the ITCZ, it forces all the pressure belts to shift northwards in winter. That's why we can see that the mid-latitude cyclone is able now to influence South Africa in winter, but not in summer. Because in summer we said that the pressure belts, they do shift further south. That is why you can see these high pressure cells, they're as well being found further southwards. And the mid-latitude cyclone, it is also located further southwards. You can see there is a greater distance between the MLOC and South Africa. This is in summer. But in winter, look, it has moved close to the land or close to South Africa, which means that our answer for this case is going to be winter. Okay. Moving to question 1.1.7, they say line A is the 40 degrees stroke 60 degrees latitude. What are latitudes? We all know latitudes. Let's go back to our blank page. Latitudes. Latitudes. Okay. Remember, these are imaginary lines. Imaginary lines which run horizontally from the east to west, horizontal. So when I say horizontal, if I try to draw our globe here to show what latitudes are, let's twist them. So we say this is a horizontal line, and we have the major line of latitude, which is the equator, which is numbered 0 degrees. We have another major latitude, which is at 30 degrees, another one at 60 degrees, and so forth, 90 degrees. Don't forget, this is the northern hemisphere. Northern hemisphere. And we all know whatever happens in the north also does happen in the southern hemisphere, meaning if we do have 30 degrees in the north, we as well have the 30 degrees to the south, because we know that latitudes, they increase northwards and southwards. So this is 0, 30, they're increasing. Another latitude, 60 degrees. We also have another one, which is 90 degrees. So you can see that these are the different, when you say imaginary lines. When you say imaginary, it means when you go there physically, you can't see this line and you say, oh, this is latitude. No, they're just imaginary lines which are invisible, but we know they are there, but they are drawn horizontally from the east to the west. Now, going back to our question, it was saying line A, is it a 40 degree or is it a 60 degree? Okay, so this is our line A here, our line A. Let me go back to our blank page for more illustration. Now, we know that mid-latitudes, there isn't the word mid. So if I remove the southern hemisphere, let me remove the northern hemisphere, for example. Let's see if it will work out the way I want. Oh, no, it won't. It won't. How do I go back? Let's see. Okay, let me try to do this one again. Technology. Let's see. Okay. What's happening now? All right. Sorry about that. So I was saying, let's try to do this again. I'm sorry, technology disappointed me. All right. Anyway, we all know that the world is not round, it's kind of oval. So I was saying, if we focus, these are the polar regions. Polar region is here, where we know it is very cold. Just say cold, and we know winds that are coming from the polar regions are going to be cold winds, right? So we have our easterlies there, and these are the subtropical belts here. I think let me try to redo this again. It's not doing what I want. All right. Let's try to make things very, very clear. I'm going to redraw our globe. Okay. Draw. Because we need to understand, not to rush, but to understand. Okay, this is the equator, like we mentioned, at 0 degrees. That's our major line of latitude. We have the other one, which is 30 degrees. We have another one, which is 60 degrees. Another one is 90 degrees. So, like I mentioned, whatever happens in the north does happen in the south. So I have the 30 degrees there. Don't forget it's a sketch. We have the 60 degrees, and we have the 90 degrees, right? So these are the polar regions here, like I mentioned. The polar region is polar, which refers to the coldest areas. Then here, this is the equator, which is warm. So meaning the winds that are coming from the equator, these winds here, these are going to be warm winds. These are coming, the winds that are coming from the polars are going to be now referred to as the cold winds. This is in the in the north. And as we know that mid-latitude cyclones, they develop where the warm winds and the cold winds meet at the polar front. So mean that this point will be our polar front. So this is in the northern hemisphere. If we go across the south, in the south as well, we do have the warm westerly winds. These are our westerly winds, and we have the cold easterly winds. Now, where do they meet? We go back to the other concept of a front. What is a front? A point where different air masses collide or meet. So meaning, at this point here in the south, this will be our polar front. Then you ask yourself, which line of latitude are they meeting at, or are they colliding at? As you can see, they don't meet at 0 degrees, they don't meet at 30, but you can see they are meeting at this line, which is 60 degrees. Of course, further could be somewhere here, but our focus is we look at the easterlies, which are coming from the polars. When they come, they are both meeting at this point, which is our polar front situated at 60 degrees. So meaning that our answer was supposed to be 60 degrees. All right, let's move on. Question 1.2. It say choose a term from column B that matches the geomorphologic description in column A. Write only the letter A to I next to the question number 1.2.1 to 1.2.8 in the answer book, for example, 1.2.9J. This is an instruction which all of you must understand, that you use letters, not words. All right. Okay. Remember, they say choose a geomorphologic description. Sorry about that. About I need to get, I think, a ruler. They say choose a geomorphologic description which matches a term in column B. Right. 1.2.1, it says the lengthening of the streams at its source due to the erosion of the watershed. What is to lengthen? Let us try to check on our blank page here. Lengthening. I'm going to give an example. Let us assume that this is a watershed. And this is a stream flowing. So it means that this point would be the source. And this point would be the mouth. So if I measure the length, for example, from the source to the mouth, if I try to measure using a ruler, for example, it could give us, let's say, we're just estimating, let's say 2.7 centimeters, right? Okay. But if you look at this other one here again, this is our watershed. For that case, watershed, then you can see that this river was able to erode through the watershed, you see, and the source extended to that point, you see. And if I measure from the centimeters from here to the mouth, it could give us, let's say, 2.9 centimeters. You see? So meaning that before this river was able to cut through the watershed, it was 2.7 centimeters in length, or it was long by 2.7 centimeters. But if you go to this one, if you check again, the river, after cutting through the watershed, it was able to extend, you know, meaning that its length was extended from 2.7 centimeters to 2.9 centimeters. All right. Let's check the question again. Question says, the lengthening of the stream at its source due to the erosion of the watershed. Okay. The lengthening of the stream at its, let me check the question once again. The lengthening of the stream at its source. Remember, they're using this concept, they're saying at its source. lengthening at its source. And I try to show it here. This is before the lengthening. This is the source. This is the watershed. But you can see here, this river is flowing to the southeast or southwards. But you can see it was able now to cut. This was cutting to erode through the watershed, whereby now its whatever course had been lengthened, or it has been stretched a bit further. Now, what is that called in geomorphology? If you check on the concept, water table, dendritic drainage, it's going to be Headward erosion. So the concept or the correct answer for this case is going to be Headward erosion as our answer. Sorry, drainage. Instead, has to be Headward erosion. What is Headward erosion? When a river erodes backwards towards its source, lengthening its channel. So that's what we refer to as Headward erosion. Okay. 1.2.2, they say river in a humid climate where the rainfall exceeds the evaporation. River in humid climate. When they say humid climate, sorry about that. When they say humid climate, humid could as well refer to areas which receives more water. Okay, more water, or always wet in most cases, always wet. That's why here they is saying rainfall. And what is evaporation? Evaporation, as we know, a process whereby water changes from one state to another state. For this case, it will be water changing from evaporation, so water changing from liquid to vapor. That is evaporation. So it's a process. Like we know that water is the only substance that you can find in many states. It can be a liquid, it can be a solid, which is ice, or it can be vapor, which is gas. Now, for water to change from liquid to vapor, there is a process which we refer to as evaporation. All right. Now, they're saying areas or a river in a humid climate where the rainfall exceeds evaporation. So it means this river, where it starts from, there is more rainfall as compared to evaporation, meaning you will always find water in that particular point. But let us see the vice versa of this statement. If, for example, it said where evaporation exceeds rainfall, it means in such areas, when you go there, you won't find water. You see, it means all the water is going to evaporate and it will disappear. But a point, sorry. Right, but so a point where rainfall exceeds vapor or evaporation, it means in that area there will always be rainfall. So which type of river will that be? Will it be an, because we check on the options, we have the episodic river, and as well we have the permanent river. But we know episodic rivers, these rivers, they only flow at a certain point when there is heavy rainfall. And permanent means this one is always there. It's always gonna be flowing. You see, that is why when we check on our options, we are going to say that it has to be the permanent river for question 1.2.2. Question 1.2.3, they say a section of a river drawn across the valley at right angles to the river. A section of a river drawn across the valley at right angles to the river. What is that going to be? Our answer is supposed to be E, which is a cross profile. A cross profile. Let us see a cross profile in details. A cross profile. So what is a cross profile? We say this one shows us the shapes of a river at different stages. If you look at the upper stage or the upper course, the shape will be deep and narrow. See, if we check the course, the river in the middle course, the shape in the middle course, which they usually refer to as the mature stage, shape will be wider. And if you check the shape in the lower course, the shape will be almost flat. Now, how do we arrive at these different courses or these different shapes? It means to be able to get the shape of a river at a different course, we apply the concept of a cross profile, where it says, for example, here, a section of a river drawn across the valley at right angles. Whenever we draw a section of a river, let's say, let's try to do something here. So when they say across, this could be the river banks, this other side. This is the channel itself. This is water. This is water. Now, if I'm to draw a cross profile around this point, it means when they say this is river bank A and bank B, which is the sides of the rivers or the edges, it means to get the shape of this point, I need to draw across a right angle. You see? Then I'll end up having something which is wider shape. So for our answer for question 1.2.3, that's why we say it's supposed to be a cross profile, because a cross profile will be able to see different shapes which are drawn across the valley at right angles. Question 1.2.4. The drainage pattern that is formed by the folded mountains. 1.2.4. Could it be, they're talking about a drainage pattern. What is a drainage pattern? The concept here is a drainage pattern. And we all understand that this refers to the shapes. The shapes of rivers, or I can also say the appearance of rivers as seen on surface. That will be a drainage pattern. Sorry. But we know that rivers do not have the same pattern or the same shape. Like human beings, we have different shapes. You see? For example, if you look at your colleague, your neighbor, your classmates, they're different shapes of us. I normally tell my learners that if you look at the shapes of our heads, you can find they are way different from each other. So as well, rivers also have different shapes depending on which type of rocks they do develop on. That's why we say for 1.2.4, the answer is supposed to be trellis. Trellis pattern, they develop in areas which have folded mountains. When they say folded mountains, what are we looking at? Folded mountains, folded. Okay, if I illustrate it here, could be something like this. That's a folded area. So if this is the main stream, for example, here, the main stream flowing, it's going to have tributaries joining from these steep areas, connecting at 90 degrees, and will end up forming a trellis pattern. It means that one side is folded, where we have a syncline and an anticline. So because of that, you can see we have the main stream in the middle, but we have tributaries that are flowing from a steeper point joining the main stream, and also this other side we have tributaries that are coming from a steeper point joining the main stream. So they will end up forming a trellis pattern. So this is common in areas which have folded mountains. As you can see, this is a fold here. That's a fold. We have a syncline here. This is another fold here. So because of these folds, if rivers are flowing in such areas, you end up forming a trellis pattern of flow. 1.2.5 occurs when the position of a watershed changes due to a more energetic stream that flows parallel to a less energetic stream. Now, our concept here is the word a watershed. If we check, this is our watershed here, and okay, so this is a watershed. Now, what is a watershed? We go back to our page here to try to understand the concept of a watershed. And I believe if you check in your textbooks, it refers to a highland that separates different drainage basins or different rivers. That is a watershed. Now, if I were to illustrate this, let's put that's a highland. You can see it's been raised. It's a watershed. Now it means on one side we have a river flowing. Let's call this river A. The other side we have another river. Let's call this one river B. Let's check the question once again. Excuse me. The question says it occurs when the position of a watershed changes due to a more energetic stream that flows parallel to a less energetic stream. So there are two concepts. Firstly, we understood what is a watershed. Now they are saying there is a more energetic stream and a less energetic stream. When they say less energetic, it's the same as a weak river. When they say energetic, it's the same as a stronger river. Let's go back to our diagram. You can see that this other side is a bit steeper, as you can see, compared to this other side, which means rivers which flow on a very steeper gradient, they become more energetic. In this one, which flows on somehow relatively gentle, we can refer to this as a less energetic stream. A less energetic stream. Now, we have understood the two concepts here. The first concept is a watershed. Another concept, energetic, less energetic, and as well we have the watershed, which is a highland. So meaning this land, it is separating river A not to mix with river B. But as you know well that when rivers are flowing, they keep on eroding materials away. You see, they keep on eroding materials away, which means, let's say, this is the point of the watershed at X, and let's say it was in 2009. That was the position of the watershed. But if we check again, after several years, you see, the watershed height has somehow reduced. This is now the watershed at point X again. Now this is in 2050. I know most of you will still be around, but if you compare the height of this watershed and this one here, the watershed here has somehow reduced, which means it is getting lower and lower. Let's check again the watershed in another year. It's the same watershed, but it keeps on changing the size. You see? Now this could be in 2093. You can see that the watershed has changed the position, or its height has gradually changed. So if we compare watershed in 2009, watershed in 2050, and the watershed in 2093, you can see that the height has simply reduced. If we go back to the question, now we have understood what they mean when they position, when they say the position of a watershed changes. What is that concept? What is that term referred to when they say occurs when the position of a watershed changes? So that will be point H, which is abstraction. So abstraction refers to the change in the position of a watershed due to more energetic stream that flows parallel to a less energetic stream. All right. Let's proceed to question 1.2.6. A drainage pattern associated with a uniform underlying rock structure. Excuse me. Now, there are two things to also understand here. They are saying uniform underlying rock structure. Don't forget, we spoke about the meaning of a drainage pattern, and we said it refers to the appearance of streams or the appearance of rivers or the shape of a river. Now, a river which is associated, the word to associate is the same as rivers which flow in such areas where the rocks are uniform. Now, if we check here. If I scroll down, say the word uniform. Uniform simply refers
GPS signal lost.
look similar. Look similar in the way they erode or resist erosion. Okay, that is uniform. So uniform, like that's why most learners in high school, primary, they put on uniforms so that they could look the same, can easily identify them. For our rocks, which are uniform, these are rocks. So it's like these rocks, they erode at the same time or they resist at the same time. Now, rivers which flow in areas which have uniform underlying rock structure, they will end up forming a pattern which is commonly known as a dendritic drainage pattern. So for 1.2.6, the answer will be dendritic drainage pattern. Let's proceed. 1.2.7, which says the upper surface of the zone of saturation in the underlying rock structure. The upper surface of the zone of saturation in the underlying rock structure. What does that mean? Okay, that's what to illustrate here. Once again, now for this question, you need to understand two concepts here. We have to understand what is surface runoff, which refers to water that flows over the surface during rainfall, to be surface runoff. And as well, we have another concept, which is infiltration. Infiltration. And this refers to a process whereby water seeps into the rocks. Or you can as well say into the ground. So that will be infiltration. Right. If you try to illustrate this on the diagram, this is the surface, for example, our surface. So this is the surface. Now underneath we have rocks. These are rocks, different layers of rocks. Be sedimentary. So these will be the rocks. Then here we have our precipitation or rainfall. You can see this is our rainfall. And we said when it rains, different processes are taking place. We see water which is able to flow over the surface, and refer to this as the surface runoff. Right. Not all water just flows over the surface. Like I mentioned, when it is raining, we're able to see water flowing over the surface, as well, some water is able to penetrate into the ground or into the rocks. You see? Now, the one which is able to penetrate into the rocks. So this process is what referred to as the process of infiltration. The process whereby water is able to penetrate into the rocks. Right. Now, the water that flows over the surface, for example, this water can flow into rivers or streams, but the one which flows into the rocks under the surface, this water is going to end up correcting. It collects here, forming for us what we call as the underground water. Remember, you can't see this water because it is hidden under in the rocks. You see, so we can call this water underground water. Underground water, or what as well referred to as the base flow. The base flow. Now, how is this water able to reach here? Because it was able to penetrate through the rocks. Right. Now, like I mentioned, this water is under the ground. You can't see it with your eyes because this is the surface. This water is just hidden inside the rocks. So this water is what we refer to as the base flow or the underground water. Now, I want us to focus on one thing here. I believe you can all see this point here, this part here. That point, that part. So that is the upper surface or the upper limit. We have the bottom part of the base flow. It's the bottom part of the base flow, the bottom part. Let's call this one point X. And the upper part, let's call it point N. See, now the upper part of the base flow is what we refer to as the water table. Referred to as the water table. So basically, when you go back to our question, which says the upper surface of the zone of saturation in the underlying rock structure. So this is the zone of saturation here. The whole of this, it is the zone of saturation. Saturation zone where water is able to settle or to squeeze itself through the rocks and it forms the base flow. But this base flow, or what we call underground water, it has the upper surface or the upper limit, which I said we can refer to as the water table. All right. So meaning our question for 1.2.7, which says the upper surface of the zone of saturation in the underlying log structure, that will be option A, which is the water table. All right. Go to question 1.2.8. The arrangement of streams and rivers in a drainage basin. I believe we have spoken about that one before. So the arrangement of streams and rivers in a drainage basin, that would be a drainage pattern. Because the way they are arranged, what does that mean? Now let's go back to our blank page. So the arrangement. So it means some rivers are arranged in such a format. This is the main river. It has tributaries. It has tributaries joining like that. So the way the tributaries are arranged, you see, it will end up giving us a shape which all of us know, which we call the dendritic. Some rivers are arranged in such a shape or such a pattern, where we see streams joining at right angles, and such a basin, we're going to refer to it as the Trellis pattern. You see, so if you check our question once again, it talks about the arrangement of streams and rivers in a drainage basin, which is the same as the shapes of rivers or the appearance of rivers. So the way they are being arranged, it will end up giving us a shape, right? So we have dendritic, trellis, we have rectangular, where the main stream has bends because it flows over jointed rocks. So this could be the rectangular. We have the centripetal, where streams flow towards one central point. It means they're coming from a higher point, going to a lower point, giving us centripetal. So this is a rectangular pattern, and this is centripetal. We as well have the ranged pattern, where streams don't have a clear pattern of flow. You see, and this one we call it deranged, which is most common in glacial areas. So this will be the deranged drainage pattern, deranged. All right, common in areas which have ice, deranged, among other. So this is just an example to show you how streams or rivers are being arranged. So it will end up giving us different shapes, which we refer to as the drainage pattern. All right, so that is question 1.2. Let's proceed to question 1.3, which says, study the synoptic weather map in figure 1.3 to answer the questions that follow. All right, now let's check the figure 1.3 for more information. This is our figure 1.3. I hope you can see we have the map of Southern Africa here. These are some of the things that you need to first identify when being given a synoptic weather map. South Africa, there's a low pressure cell over the interior. We have a high pressure cell the other side, another one this way. There's a stationary model here which has been enlarged for this from this point. And as well, you can see there is a cold front here, another cold front here. We have isobars at this particular point, and you can see pressure decreasing towards the low pressure cell and increasing towards the high pressure cell. So they say this is Durban here. They show us time and the date at this point here. All right, let us now go back to the questions to try to understand. They say, identify the high pressure cell A. Let's check the question once again. They say, identify high pressure cell A. High pressure cell A. Now, as you can see, this is our high pressure cell at A. And of course, we know that the one which forms to the west of South Africa or Southern Africa, of course, this is This is Southern Africa. This is our Southern Africa, or South Africa in particular. Now, this is the western side, and this is the eastern side. And we know here it is the Atlantic Ocean. So we have the Atlantic Ocean, which develops over the western side. So meaning that the high pressure cell which is found at point A, it will be referred to as the South Atlantic high pressure cell. South Atlantic high pressure cell. Or we can as well give it another name, which will refer to it as St. Helena. St. Helena High. That is found to the west of South Africa. Now, since we have spoken about South Atlantic High found to the west, or St. Helena, remember it has two names. It can be referred to as St. Helena High or South Atlantic High. Now, this one, which is found to the east of South Africa. So we are going to refer to this as the South Indian high pressure. It also has another name. It has another name which I could as well, if I go back to our blank page. But we said that we have South Atlantic High in bracket St. Helena High. And as well, I want us to talk about the other one found to the east, which is South Indian High, or can as well be called Mauritius High. Right. Okay. So for our question 1.3.1, we said identify the high pressure cell at A, which is we said supposed to be South Atlantic high pressure, or St. Helena High. One mark. Question 1.3.2. Identify the front at B. Identify the front at B. This is our front at B here. As you can see, this is B here. We're referring to this front here. And which all of us know, it means we look at the symbol. This symbol which looks sharp pointed, or which looks, in some books they show it as a triangle. So for this case, it will be a cold front. So meaning for question 1.3.2 to be a cold front. Right. 1.3.3, they say give the air pressure at A. Give the air pressure at A. So give the air pressure at A. Let's check A once again. All right. So if we check, this is A here. We look at the isobars, 996, 1000, 1004. So you can see the pressure interval is 4, because when you add 996 and you add 4 to give us 1000 plus 4, 1004 plus 4, 1008 plus 4, 1012 plus 4, 1016 plus 4, 1020 plus 4, which give us 1024. What does that indicate? It means we can see that pressure is increasing towards the center, which typically means that this is a high pressure cell, right? Now, if they say, what is the air pressure at A? You see, so it means we could say, because we don't see any isobar here, so we cannot say the different. We cannot bring in the pressure, the isobar interval here, because we don't see any other isobar. If it was like this, we are going to easily say, just going to add before, and we say 1028. But the challenge is there's no isobar to indicate the missing figure. Therefore, what do we do for that case? We could say that at A, the air pressure is increasing. So you could say that the pressure at A, it is increasing, or we could say it is a high pressure, or we could as well say the pressure, it is 1025, 1026, 1027. So just add 1, you see? So you could as well say it is 1025, 1026, 1027. But we do not give the pressure interval, because there is no isobar which has been indicated. Like I mentioned before, we don't have any isobar here. If it was an isobar, we could just going to say we were just going to use the pressure interval. For this case, we know that the pressure at A, it is increasing, or it is a high pressure. We could just say it is 1025, 1026, 1027, but we do not give 1028. That would indicate that there is an isobar and which we cannot see. All right. Let's proceed to the question 1.3.4. What evidence in the area C shows that strong winds are experienced? What evidence shows that in area C, there are strong winds? All right. Let's go check area C. Now, this is our area C here. Our area C here. What can you observe at area C? Because we know winds are moved from high pressure going to the low pressure. And we know that winds are very strong where isobars are close to each other. Therefore, when we check the question, it says, what evidence in area C shows that strong winds are experienced? Let's go back to the diagram. This is our area C, but like I mentioned, whenever you see, these are isobars, right? These are isobars. But look, see how close they are to each other. You see, especially around this point. Isobars are so close to each other. And where isobars are close to each other, that shows, it indicates a steeper gradient, or it indicates where the winds are moving very fast. So basically, you look at the isobars where they are too close to each other, that shows that the movement of the wind is very strong at that particular point. Therefore, when we say the answer here, what evidence in area C, winds are strong. So we could write and we say, because the isobars are close to each other, isobars are close to each other. Now Now, that is one of the indications to show that the winds are very strong. All right. So isobars are close to each other. That's one indication that strong winds are being experienced there. And as well, I can as well say, sorry, and as well say, we said isobars are close to each other. And that's what we could do as well say that steep gradient indicated by the isobars. So that shows that the winds are strong in that particular point. Right. Let us proceed to question 1.3.5. They said, give a reason for the cloudy cover to the east of heat low pressure. Give a reason for the cloudy cover. The cloudy cover, the east of a heat low pressure. Now, what is a heat low pressure? Let's go back to the diagram here. What is a heat low pressure? We know well. Just try to illustrate again. Map of Southern Africa. Where in the interior here have LOP, meaning a low pressure cell, and the name of this low pressure cell is what we refer to as a heat low. Sometimes you can as well call it a thermal low pressure cell. So it is a heat low or a thermal low pressure cell. It does develop in summer due to intense heating of the land, therefore forming a low pressure. So in winter, because of there is strong subsidence, the thermal low disappears and the Kalahari will dominate the interior. So this is one of the indications to show that we are in summer season as a result of the presence of the thermal low. Okay, going back to our question, it says, give a reason for the cloudy cover to the east of a heat low pressure. Let's check the diagram here. This is a heat low, and it's a heat low here. They sent to the east of a heat low. Let me check the question once again. Give a reason for the cloudy cover to the east of a heat low. So you can see, this is the east of a heat low. You can see, do you see these dark spots? So all these ones are indicating cloudy covers, see? And if we check, all these are overcast cloudy covers, you see? What does that mean? That there are a lot of clouds that have formed to the east of a heat low. But the question is, let's check the question once again. Give a reason for the cloudy cover. Why are we experiencing a lot of overcast clouds at this particular point? That is the question. So you could say, if you go back to our blank page, reason for the cloudy cover, you could say because of a lot of evaporation taking place due to high temperatures. due to high temperatures. Also, I could say there's a lot of humid from the South Indian high pressure, resulting into high condensation. Another one as well say the inversion layer is above the escarpment. Inversion layer is above the escarpment, resulting into high cloud formation, which we refer to as condensation. All right. Let me try to illustrate these concepts below. A lot of evaporation taking place due to high temperatures. What is evaporation? Like we mentioned, ladies and gentlemen, when the temperatures are too high, water changes state from being liquid to vapor. So when this water changes, let's put water here as an illustration. This is water, high temperatures. So there is the sun there. High temperature. So this is water in a liquid. So when it is too hot, now this water changes from being liquid to gas. When it rises to the dew point here, let's say it's the dew point, this was going to change into liquid again, which is the same as condensation, forming clouds. Right. So like that, that's why we say that in summer, because temperatures are too high, they make water to change from being liquid to gas, which ends up condensing at the dew point, forming clouds or a lot of humid from the South Indian high pressure cell, resulting into high condensation. If I illustrate that concept as well, this is Southern Africa here. This is the Indian Ocean here. I have the Indian Ocean. The Indian Ocean, it causes a lot of humid, which comes over the land on the eastern side, resulting into a lot of condensation taking place. And when there is a lot of condensation taking place, it means now we shall end up having a lot of clouds that are going to form. That will be for option number 2. If you check option number 3, where they say the inversion layer is above the escarpment, resulting into high cloud formation, then we can as well do illustrate it here, and we show. Sorry. Okay, let us try to show this. We show our escarpment there. Show the inversion layer. Escarpment. I can try to show the inversion layer. So the inversion layer. Inversion layer. Above escarpment. So this means that we're going to have, shall have our moist air coming all the way, humid from the Indian Ocean. So this is able to reach over the interior, and it's going to condense as well, resulting into overcast conditions. Remember the concept, the question is asking why there are a lot of cloud formation. So we have indicated the clouds here due to the inversion layer being above the escarpment. This is the inversion layer. This is the escarpment or the plateau. So because we know that in winter, the inversion layer does shift downwards, which might end up blocking the warm moist air from the Indian Ocean. But in summer, you can see it has shifted upwards from the escarpment, which is going to result into warm moist air reaching the interior to condense, forming clouds. And here we mentioned as well, we have the warm moist air from the Indian Ocean reaching the interior or reaching the eastern side, condensing, forming clouds. And as well here we said, because of high temperatures, water changes to vapor and resulting into condensation, forming clouds. So that is how we can try to answer that question. All right, let's proceed. Question 1.3.6 says, besides the date, what evidence suggests that this is a summer synoptic map? All right, we try to remove this, but we can have our synoptic map once again clear for visibility. All this. Right. So we have our synoptic map clear once again. They say, besides the date, what evidence suggests that this is a summer synoptic map? Our focus is on the concept summer. Summer, right. So how do we indicate, or how do we tell that this is a summer synoptic? End up forming a trellis pattern of flow. 1.2.5 occurs when the position of a watershed changes due to a more energetic stream that flows parallel to a less energetic stream. Now, our concept here is the word a watershed. If we check, this is our watershed here, and okay, so this is a watershed. Now, what is a watershed? We go back to our page here, try to understand the concept of a watershed. And I believe if you check in your textbooks, it refers to a highland that separates different drainage basins or different rivers. That is a watershed. Now, if I were to illustrate this, let's put that's a highland. You can see it's been raised. It's a watershed. Now it means on one side we have a river flowing. Let's call this river A. The other side we have another river. Let's call this one river B. Let's check the question once again. Excuse me. Now the question says, it occurs when the position of a watershed changes due to a more energetic stream that flows parallel to a less energetic stream. So there are two concepts. Firstly, we understood what is a watershed. Now they are saying there is a more energetic stream and a less energetic stream. When they say less energetic, it's the same as a weak river. And when they say energetic, the same as a stronger river. Let's go back to our diagram. You can see that this other side is a bit steeper, as you can see, compared to this other side, which means rivers which flow on a very steeper gradient, they become more energetic. In this one, which flows on somehow relatively gentle, we can refer to this as a less energetic stream. A less energetic stream. Now, we have understood the two concepts here. The first concept is a watershed. Another concept, energetic, less energetic, and as well we have the watershed, which is a high land. So meaning this land, it is separating river A not to mix with river B. But as you know well that when rivers are flowing, they keep on eroding materials away. You see, they keep on eroding materials away, which means, let's say, this is the point of the watershed at X, and let's say it was in 2009. That was the position of the watershed. But if we check again, after several years, you see, the watershed height has somehow reduced. This is now the watershed at point X again. Now this is in 2050. 2050, I know most of you will still be around, but if you compare the height of this watershed and this one here, the watershed here has somehow reduced, which means it is getting lower and lower. Let's check again the watershed in another year. It's the same watershed, but it keeps on changing the size. You see? Now this could be in 2093. You can see that the watershed has changed the position, or its height has gradually changed. So if we compare watershed in 2009, watershed in 2050, and the watershed in 2093, you can see that the height has simply reduced. If we go back to the question, now we have understood what they mean when when they say the position of a watershed changes. What is that concept? What is that term referred to when they say occurs when the position of a watershed changes? So that will be point H, which is abstraction. So abstraction refers to the change in the position of a watershed due to more energetic stream that flows parallel to a less energetic stream. All right. Let's proceed to question 1.2.6. A drainage pattern associated with a uniform underlying rock structure. Excuse me. Now, there are two things to also understand here. They are saying uniform underlying rock structure. Don't forget, we spoke about the meaning of a drainage pattern, and we said it refers to the appearance of streams, or the appearance of rivers, or the shape of a river. Now, a river which is associated, the word associate is the same as rivers which flow in such areas where the rocks are uniform. Now, if we check here, If I scroll down, say the word uniform. Uniform simply refers
GPS signal lost.
look similar. Look similar in the way they erode or resist erosion. Okay, that is uniform. So uniform, like that's why most learners in high school, primary, they put on uniforms so that they could look the same, can easily identify them. For our rocks, which are uniform, these are rocks. So it's like these rocks, they erode at the same time or they resist at the same time. Now, rivers which flow in areas which have uniform underlying rock structure, they will end up forming a pattern which is commonly known as a dendritic drainage pattern. So for 1.2.6, the answer will be dendritic drainage pattern. Let's proceed. 1.2.7, which says the upper surface of the zone of saturation in the underlying rock structure. The upper surface of the zone of saturation in the underlying rock structure. What does that mean? Okay, that's why to illustrate here. Once again, now for this question, you need to understand two concepts here. We have to understand what is surface runoff, which refers to water that flows over the surface during rainfall, to be surface runoff. And as well, we have another concept, which is infiltration. Infiltration. And this refers to a process whereby water seeps into the rocks. Or you can as well say into the ground. So that will be infiltration. Right. If you try to illustrate this on the diagram, this is the surface, for example, our surface. So this is the surface. Now underneath we have rocks. These are rocks, different layers of rocks. Be sedimentary, and so these will be the rocks. Then here we have our precipitation or rainfall. You can see this is our rainfall. And we said when it rains, different processes are taking place. We see water which is able to flow over the surface, and refer to this as the surface runoff. Right. not all water just flows over the surface. Like I mentioned, when it is raining, we're able to see water flowing over the surface. As well, some water is able to penetrate into the ground or into the rocks. You see? Now, the one which is able to penetrate into the rocks. So this process is what referred to as the process of infiltration. The process whereby water is able to penetrate into the rocks. Right. Now, the water that flows over the surface, for example, this water can flow into rivers or streams, but the one which flows into the rocks under the surface, this water is going to end up correcting. It collects here, forming for us what we call as the underground water. Remember, you can't see this water because it is hidden under in the rocks. You see, so we can call this water underground water. Underground water, or what as well referred to as the base flow. The base flow. Now, how is this water able to reach here? Because it was able to penetrate through the rocks. Right. Now, like I mentioned, this water is under the ground. You can't see it with your eyes because this is the surface. This water is just hidden inside the rocks. So this water is what we refer to as the base flow or the underground water. Now, I want us to focus on one thing here. I believe you can all see this point here, this part here. That point, that part. So that is the upper surface or the upper limit. We have the bottom part of the base flow. It's the bottom part of the base flow, the bottom part. Let's call this one point X. And the upper part, let's call it point N. See, now the upper part of the base flow is what we refer to as the water table. Referred to as the water table. So basically, when you go back to our question, which says the upper surface of the zone of saturation in the underlying rock structure. So this is the zone of saturation here. The whole of this, it is the zone of saturation. Saturation zone, where water is able to settle or to squeeze itself through the rocks, and it forms the base flow. But this base flow, or what we call underground water, it has the upper surface or the upper limit, which I said we can refer to as the water table. All right. So meaning our question for 1.2.7, which says the upper surface of the zone of saturation in the underlying log structure, that will be option A, which is the water table. All right. Go to question 1.2.8. The arrangement of streams and rivers in a drainage basin. I believe we have spoken about that one before. So the arrangement of streams and rivers in a drainage basin, that would be a drainage pattern. Because the way they are arranged, what does that mean? Now let's go back to our blank page. So the arrangement. So it means Some rivers are arranged in such a format. This is the main river. It has tributaries. It has tributaries joining like that. So the way the tributaries are arranged, you see, it will end up giving us a shape which all of us know, which we call the dendritic. Some rivers are arranged in such a shape or such a pattern, where we see streams joining at right angles, and such a basin, we're going to refer to it as the Trellis pattern. You see, so if you check our question once again, it talks about the arrangement of streams and rivers in a drainage basin, which is the same as the shapes of rivers or the appearance of rivers. So the way they are being arranged, it will end up giving us a shape, right? So we have dendritic, trellis, we have rectangular, where the main stream has bends because it flows over jointed rocks. So this could be the rectangular. We have the centripetal, where streams flow towards one central point. It means they're coming from a higher point, going to a lower point, giving us centripetal. So this is a rectangular pattern, and this is centripetal. We as well have the ranged pattern, where streams don't have a clear pattern of flow. You see, and this one we call it deranged, which is most common in glacial areas. So this will be the deranged drainage pattern, deranged. All right, common in areas which have ice, deranged, among other. So this is just an example to show you how streams or rivers are being arranged. So it will end up giving us different shapes, which we refer to as the drainage pattern. All right, so that is question 1.2. Let's proceed to question 1.3, which says, study the synoptic weather map in figure 1.3 to answer the questions that follow. All right, now let's check the figure 1.3 for more information. This is our figure 1.3. I hope you can see we have the map of Southern Africa here. These are some of the things that you need to first identify when being given a synoptic weather map. South Africa, there's a low pressure cell over the interior. We have a high pressure cell the other side, another one this way. There's a stationary model here which has been enlarged for this from this point. And as well, you can see there is a cold front here, another cold front here. We have isobars at this particular point, and you can see pressure decreasing towards the low pressure cell and increasing towards the high pressure cell. So they say this is Durban here. They show us time and the date at this point here. All right, let us now go back to the questions to try to understand. They say, identify the high pressure cell A. Let's check the question once again. They say, identify high pressure cell A. High pressure cell A. Now, as you can see, this is our high pressure cell at A. And of course, we know that the one which forms to the west of South Africa or Southern Africa. Of course, this is Southern Africa. This is our Southern Africa or South Africa in particular. Now, this is the western side, and this is the eastern side. And we know here it is the Atlantic Ocean. So we have the Atlantic Ocean, which develops over the western side. So meaning that the high pressure cell which is found at point A, it will be referred to as the South Atlantic high pressure cell. South Atlantic high pressure cell. Or we can as well give it another name, which will refer to it as St. Helena. St. Helena High. That is found to the west of South Africa. Now, since we have spoken about South Atlantic High found to the west or St. Helena, remember it has two names. It can be referred to as St. Helena High or South Atlantic High. Now, this one which is found to the east of South Africa. So we are going to refer to this as the South Indian high pressure. It also has another name. It has another name which I could as well, if I go back to our blank page. But we said that we have South Atlantic High in bracket St. Helena High. And as well, I want us to talk about the other one found to the east, which is South Indian High, or can as well be called Mauritius High. Right. Okay. So for our question 1.3.1, we said identify the high pressure cell at A, which is we said supposed to be South Atlantic high pressure or St. Helena High. On mark. Question 1.3.2. Identify the front at B. Identify the front at B. This is our front at B here. As you can see, this is B here. We're referring to this front here. And which all of us know, it means we look at the symbol. This symbol which looks sharp pointed, or which looks, in some books they show it as a triangle. So for this case, it will be a cold front. So meaning for question 1.3.2 to be a cold front. Right. 1.3.3, they say give the air pressure at A. Give the air pressure at A. So give the air pressure at A. Let's check A once again. All right. So if we check, this is A here. We look at the isobars, 996, 1000, 1004. So you can see the pressure interval is 4, because when you add 996 and you add 4 to give us 1,000 plus 4, 1,004 plus 4, 1,008 plus 4, 1,012 plus 4, 1,016 plus 4, 1,020 plus 4, which give us 1,024. What does that indicate? It means you can see that pressure is increasing towards the center, which typically means that this is a high pressure cell, right? Now, if they say what is the air pressure at A, you see, so it means we could say, because we don't see any isobar here, so we cannot say the different. We cannot bring in the pressure, the isobar interval here, because we don't see any other isobar. If it was like this, we are going to easily say, just going to add before, and we say 10, 28. But the challenge is there's no isobar to indicate the missing figure. Therefore, what do we do for that case? We could say that at A, the air pressure is increasing. So you could say that the pressure at A, it is increasing, or we could say it is a high pressure, or we could as well say the pressure, it is 1025, 1025, 1026, 1027. So just add 1, you see? So you could as well say it is 1025, 1026, 1027. But we do not give the pressure interval, because there is no isobar which has been indicated. Like I mentioned before, we don't have any isobar here. If it was an isobar, we could just going to say we were just going to use the pressure interval. For this case, we know that the pressure at A, it is increasing, or it is a high pressure. We could just say it is 1025, 1026, 1027, but we do not give 1028. That would indicate that there is an isobar and which we cannot see. All right. Let's proceed to the question 1.3.4. What evidence in the area C shows that strong winds are experienced? What evidence shows that in area C, there are strong winds? All right. Let's go check area C. Now, this is our area C here. Our area C here. What can you observe at area C? Because we know winds are moved from high pressure going to the low pressure. And we know that winds are very strong where isobars are close to each other. Therefore, when we check the question, it says, what evidence in area C shows that strong winds are experienced? Let's go back to the diagram. This is our area C. But like I mentioned, whenever you see, these are isobars, right? These are isobars. But look, see how close they are to each other. You see, especially around this point. Isobars are so close to each other. And where isobars are close to each other, that shows, it indicates a steeper gradient, or it indicates where the winds are moving very fast. So basically, you look at the isobars where they are too close to each other, that shows that the movement of the wind is very strong at that particular point. Therefore, when we say the answer here, what evidence in area C, winds are strong. So we could write and we say, because The isobars are close to each other. Isobars are close to each other. Now, that is one of the indications to show that the winds are very strong. All right. So isobars are close to each other. That's one indication that strong winds are being experienced there. And as well, I can as well say, sorry, and as well say, we said isobars are close to each other. And that's what we could as well say that steep gradient indicated by the isobars. So that shows that the winds are strong in that particular point. Right. Let us proceed to question 1.3.5. They said, give a reason for the cloudy cover to the east of heat low pressure. Give a reason for the cloudy cover. The cloudy cover, the east of a heat low pressure. Now, what is a heat low pressure? Let's go back to the diagram here. What is a heat low pressure? We know well. Just try to illustrate again. Map of Southern Africa. Where in the interior here have LOP, meaning a low pressure cell, and the name of this low pressure cell is what referred to as a heat low. Sometimes you can as well call it a thermal low pressure cell. So it is a heat low or a thermal low pressure cell. It does develop in summer due to intense heating of the land, therefore forming a low pressure. So in winter, because of there is strong subsidence, the thermal low disappears and the Kalahari will dominate the interior. So this is one of the indications to show that we are in summer season as a result of the presence of the thermal low. Okay, going back to our question, it says, give a reason for the cloudy cover to the east of a heat low pressure. Let's check the diagram here. This is a heat low, and it's a heat low here. They sent to the east of a heat low. Let me check the question once again. Give a reason for the cloudy cover to the east of a heat low. So you can see, this is the east of a heat low. You see these dark spots. So all these ones are indicating cloudy covers, see? And if we check, all these are overcast cloudy covers, you see? What does that mean? That there are a lot of clouds that have formed to the east of a heat low. But the question is, let's check the question once again. Give a reason for the cloudy cover. Why are we experiencing a lot of overcast clouds at this particular point? That is the question. So you could say, if you go back to our blank page, reason for the cloudy cover, you could say because of a lot of evaporation taking place due to high temperatures. Due to high temperatures. Also, I could say there's a lot of humid from the South Indian high, South Indian high pressure, resulting into high condensation. Another one, as well say, the inversion layer is above the escarpment. Inversion layer is above the escarpment, resulting into high cloud formation, which we refer to as condensation. All right. Let me try to illustrate these concepts below. A lot of evaporation taking place due to high temperatures. What is evaporation? Like we mentioned, ladies and gentlemen, when the temperatures are too high, water changes state from being liquid to vapor. So when this water changes, let's put water here as an illustration. This is water, high temperatures. So there is the sun there. High temperature. So this is water in a liquid. So when it is too hot, now this water changes from being liquid to gas. When it rises to the dew point here, let's say it's the dew point, this was going to change into liquid again, which is the same as condensation, forming clouds. Right. So like that, that's why we say that in summer, because temperatures are too high, they make water to change from being liquid to gas, which ends up condensing at the dew point, forming clouds or a lot of humid from the South Indian high pressure cell, resulting into high condensation. If I illustrate that concept as well, this is Southern Africa here. This is the Indian Ocean here. I have the Indian Ocean. The Indian Ocean, it causes a lot of humid, which comes over the land on the eastern side, resulting into a lot of condensation taking place. And when there is a lot of condensation taking place, it means now we shall end up having a lot of clouds that are going to form. That will be for option number 2. If you check option number 3, where they say the inversion layer is above the escarpment, resulting into high cloud formation. Then we can as well do illustrate it here, and we show. Sorry. Okay, let us try to show this. We show our escarpment there. Show the inversion layer. Escarpment. I can try to show the inversion layer. So the inversion layer. Inversion layer. have escarpment. So this means that we're going to shall have our moist air coming all the way, humid from the Indian Ocean. So this is able to reach over the interior, and it's going to condense as well, resulting into overcast conditions. Remember, the question is asking why there are a lot of cloud formation. So we have indicated the clouds here due to the inversion layer being above the escarpment. This is the inversion layer. This is the escarpment or the plateau. So because we know that in winter, the inversion layer does shift downwards, which might end up blocking the warm moist air from the Indian Ocean. But in summer, you can see it has shifted upwards from the escarpment, which is going to result into warm moist air reaching the interior to condense, forming clouds. And here we mentioned as well, we have the warm moist air from the Indian Ocean reaching the interior or reaching the eastern side, condensing, forming clouds. And as well here we said, because of high temperatures, water changes to vapor and resulting into condensation, forming clouds. So that is how we can try to answer that question. All right, let's proceed. Question 1.3.6 says, besides the date, what evidence suggests that this is a summer synoptic map? All right, we try to remove this, but we can have our synoptic map once again clear for visibility. All this. Right. So we have our synoptic map clear once again. They say, besides the date, what evidence suggests that this is a summer synoptic map? Our focus is on the concept summer. Summer, right? So how do we indicate, or how do we tell that this is a summer synoptic map? Let's go to our blank page so we can write down our answers. Good. The first evidence was just asking to give evidence. Evidence is what you can see, right? Among the evidences to show that this is summer, we can talk about the presence of a thermal low dominating the interior. So you can say presence of thermal low stroke heat low dominating the interior or land, right? That's one evidence. Like I mentioned before, if it was winter, in most cases, we're going to see the high pressure cell where they will indicate with an H here, if it was winter, to show that that's a Kalahari which is dominating the land if it was winter. But since we are in summer, we have the thermal low dominating the land. Another evidence can also talk about a lot of overcast clouds. You can see all these overcast clouds. It means clouds have been forming or developing. And this is common in summer, because we know in summer, due to high temperatures, water is able to change state and then condenses, forming clouds. So meaning, we could talk about presence of overcast conditions. Overcast conditions over the interior. Over the interior. Another evidence that we can talk about, can as well talk about the mid-latitude cyclone. I did hint before previously, I think it was the first question, that normally look at the position of the mid-latitude cyclones. You can see that they are far away from the land. See? So if this happens, so we are going to say that the mid-latitude cyclone, is situated far away from the land. And this is typical, or this is common in summer. Another evidence, and as we will use this stationary model for Durban, if you check on this stationary model, look at the air temperatures, way high the dew point temperatures. See, so high temperatures also does indicate that we are in summer season, right? Let's say high temperatures, or air temperatures, and also high dew point temperature. Remember, this is common in summer season. All right. Okay. Can as well talk about the two high pressure sources, because we mentioned before that this is South Atlantic high and this is South Indian high. You can see that they are situated far away from the coast. See, this is South Atlantic high, it's really far away, and this is South Indian high as well, situated far away from the land. So therefore, we can say that South Atlantic high, South Atlantic high, and South Indian high are situated far away from the land. Far from the land. All right. Question 1.3.7. They say, with reference to the South Indian in bracket Mauritius high pressure situated east of Durban, explain the weather conditions experienced at Durban. All right, let's go to Durban. So this is the station model, which is found at Durban. Let me remove this, make it clear. Okay, so we can start with the wind direction is northeast, and we are going to say the me draw another line here to separate this from this other question. Say wind direction is northeast as a result of anti-clockwise rotation. Sort of anti-clockwise rotation. Okay. Then another one. Let's go back to the station model. Look at the wind speed is just 15 knots. See, 15 knots. So you could say wind speed is 15 knots, which is due to isobars being far from each other. Isobars being far from each other. So you can see that around Durban, the isobars are stood far from each other. So one isobar here, another one here, and this shows a weak pressure gradient, which means the winds are not that very strong. This is the identification. So you can see we have this isobar here, another one here. So if you look at around Durban, you can see that the pressure gradient is weak, which means the wind's speed was not high. See, all right. Let's check another concept, another condition. Okay. So we have overcast conditions. Overcast conditions due to a lot of moist air being fed from the Indian high pressure cell. So as you can see here, this is our Indian high pressure cell. So it brings a lot of moisture towards this other point. So this moisture is going to result into high rate of condensation taking place, causing too much of the overcast. So it means that moist air is being brought to this point, moist air. So this moist air will end up condensing, forming a lot of overcast clouds over this other point. So that is why we say on our answer sheet, there will be a lot of overcast condition due to a lot of moist air being fed from the Indian high pressure cell. So if you go back again, you can see there are high temperatures. What is causing that? So you could say high temperatures due to warm air subsiding over Durban. subsiding over Durban. So it means that a lot of warm air is coming from the interior towards Durban. As you can see here, we have a lot of warm air that is subsiding over the Durban area, resulting into temperatures to be that high. Then another one, the high dew point temperature, as well say high dew point temperature, which is due to a lot of moist air, being fed over Durban, meaning this warm moist air is going to result into high rate of condensation. All right, so that is question 1.3. Let us proceed to question 1.4, which talks about figure 1.4 shows the formation of a traveling disturbance known as a line thunderstorm. Right. So this is our figure below showing a line thunderstorm. Let's try to move faster. Question 1.4.1, they say, name the season during which line thunderstorms do occur. All right. Now, to understand this concept, we need to understand what is pressure gradient. Let's go back to our answer sheet. Understand what is pressure gradient. Sorry, draw a straight line. Okay. This is much more better. Right. Now, pressure gradient so it refers to the difference in pressure. For example, e.g., we have point A, which has a high pressure, and point B, which has a low pressure. So we can refer to this as pressure gradient. As pressure, sorry, okay, so we're going to refer to this as pressure gradient, because you can see that area A has a high pressure and area B